Good morning, everyone. This is our first session of current affairs for Mains 2025. Today, as you know, we are having science and tech coverage. So you might be aware, like how we have designed this course. It has two parts. One thing is the PDF material. This is an essential part of this program. And what we have done, the amount of effort that gone to make this PDF, what is the whole objective is, like to score marks, you need to do few things correctly. First thing is having correct structure to the answer. Like this is a very common mistake. Even I have seen in students who have like written quite few mains and still making mistakes in understanding the demand of the question, or not structuring answer, like space allocation. What you spend few more seconds on understanding the question. What is the context of the question? Why this particular topic is being asked? What exactly is asked? What exactly is asked? That should occupy the major part. If it is a 10 markers, say 2 pages you have to fill, 1.5 or more than 1.5 pages should be exactly what is asked. Rest, if way forward is not asked and you are adding it, or government initiatives not asked and still you are adding it, or you are writing an extended introduction, you can do all of this, but it should be limited to half a page. 1.5 page should be exactly what is asked. This is one mistake you need to avoid. What is other thing? If you are comfortable with structuring the answer, the other thing you need to keep in mind to score say 450 or 460 marks in mains is having quality content. Having quality content in your answers, and how quality content you can bring in your answer sheet. See, science and tech, three subjects which I particularly deal with: international relations, security, internal security, and science tech. In all these three subjects, mostly the questions are current based questions. IR, if you look, almost 4 questions are exactly current based questions. Same goes with internal security and science tech. Now, to bring the problem with this, like we have seen this with a lot of students who are writing test series. Like you think that you know the context. You think that suppose a question is on India-West Asia relations. You know decent content on West Asia. I accept that. You know why West Asia is important. Everyone know this crude oil is coming from West Asia. Everyone know India has relations with UAE, with Saudi Arabia, with dehyphenation policy. These peripheral knowledge in these 3 subjects everyone have, and we get questions in a generalistic tone. You might have read this topic in newspapers, you might have read these topics in books, or for prelims you will be having a fair idea on the topic. Now people try to think that this idea is enough to score good marks in mains. That is an absurd mistake. This is something you need to understand. Scoring marks in mains and having conceptual, overall, peripheral, top of the view understanding, these 2 things are not equal. You need to go beyond your over the view understanding of the subject. And how you can do this, how this happens. For this you have to invest in making notes. You have to collect points. For example, suppose the question came on Iran-Israel conflict. Now, as I told you in the previous video, like only thing that matters, if you have compiled every static information related to Iran-Israel conflict in 1 page, and you have revised these notes, say for 3 times, 4 times, 5 times, then you can replicate these notes in your mains examination. Then your points will have a qualitative stuff. Then your points will have an upper edge over somebody sitting next to you. Then there is scope, you can score say for 50 plus marks in mains. Unless this is not happening, say for 20 question in one GS paper. If this is not happening, so 15 plus questions, you are not going to score in 450. You are up मन की बात paper में लिख के आ रहा है. Like you are over your peripheral understanding, you are filling the papers. You will feel very satisfied. I have written the papers. Maybe last time I was not having good content in many questions. Today I have peripheral knowledge for more questions and I have written more. When result come, it will be again shocking to you. You will be wondering why I am still stagnant at 320 or 350 or 340 marks. And this is the reason. You need to go beyond your peripheral understanding. And if I say it very openly, रटना चाहिए. बहुत ज़्यादा content आपको लिख के एक जगह रख के रटना चाहिए. You had simply had to by heart memorize it. This phase is your mains preparation. This is the whatever time now is left is for this memorization process. And this is where this whatever whole work, consolidating material in one place, giving you some instincts, some ideas to how to memorize this, giving you a broad understanding of what are the key facts, figures, numbers, examples you should not miss in a subject. All these element is consolidated in this PDF. So structuring the answer for baking a qualitative points, whatever you necessary is covered in this point, this notes. Hope I make the prefix clear. What as a student I expect from you. I know you will be having your own notes. You will be having your own IR notes or science and technology notes or security notes or any other subject. You will be having your own current affairs, newspaper notes. I'm not saying you to like disregard your notes. Your notes is your primary base material. Now this is an add-on over it. Whatever is the Kalam IAS providing these materials, current affairs materials, this should be an add-on into your notes. And whenever you are having test, revise these notes, go through these notes, then go to the test. Then you can see how your qualitative approach to the question changes. Even if a tough question asks, you know the basic premises, you know the basic understanding, you know basic facts and figures regarding the particular sector. You can address that satisfactorily. Getting? Let's go ahead. So this is the whole promise, providing, outsourcing this consolidation of materials in one place. This is exactly what is provided to you. And your responsibility is complement it with your notes and revise it and come and write the test. And revise it 4 times. 4 tests you are giving for IR, 4 times you revise. Then next day you give the test. Then we will see qualitative improvements. That is the only key to score for 50 plus in your marks. And for mains, it's not like prelims, there is predictability. And from last few years, what we have seen, every question, every year 4 question, you get from 5 question every paper, you get from our current affairs notes, our current affairs PDFs. So these are very, very critically important PDFs. So take this very importantly and revise it. Go ahead. So this is material PDF you can download from your portal. Coverage, you can see extensive coverage is given. It is divided according to the syllabus, and an extensive coverage is provided here. It is not just a current affairs material, or current affairs as well as static themes which are concurrently asked, like themes like achievements of Indians in science and technology, like Srinivasa Ramanujan, CV Raman, few scientists which are very prominent, and PYQs as schemes. You might remember M. Vishwesvaraya, there was a PYQ. So these kind of static themes also we are included in this material. You can go through the index for much detailed overview of what exactly is covered in this content. Rest beyond that, from current affair perspective, every news article we have broken down, like whatever is published in the Hindu, the Indian Express and PIB. This is a consolidation of daily exercise of compiling these sources over last one year, 1.5 years. So from coverage perspective, you don't need to worry too much. Everything that is relevant is ditto covered in these booklets. So on that note, we will start with the content. So the first part of your syllabus, science and technology, developments and its applications and effects in everyday life. Electronic toll collection. This why this particular thing is in when we speak everyday life, science and technology in everyday life. This is a highly broad subject. There is no easy way to predict exactly questions from this. Last year you have this question from electronic toll collection. Previously you had question from LEDs. You can get questions from biotech related to everyday life applications. You can get questions from light applications, lidar, laser, these kind of applications. So this is a highly broad subject. So we are not too much getting into these subjects. For electronic toll collection, what exactly was asked? Again, when you get questions, if you look at the trend of what PYQs has been asked previously, technology, what you have to learn is a brief understanding of technology. You don't need to dig deeper or have a precise understanding what are the technical aspects going inside it. No, that is not required. You need a peripheral understanding of the technology, keywords, few keywords required regarding this. At least 2-3 keywords is there, you can just make up this. Second is applications you have to learn. Third is if a technology is in use, like the electronic toll collection, you need to understand the benefits or limitations. These aspects you cannot miss out, then you can give a way forward. If some government initiatives is related to this, then that also you need to take a note. That is the overall how you approach this section. Mostly questions are very generic. It is not like you will get something where you doesn't know anything. This kind of question hardly comes from this particular section, like science and technology in everyday life. But still you need a aptitude to write this question. You need to practice these in test series. For example, we'll see this electronic toll collection. Everyone know how this electronic, you might have studied this for prelims, you might have read this in newspapers, you might have exactly experienced this when passing through different toll collection booths. So what technology FASTag is being introduced, and on what technology FASTag is working on? RFID, radio frequency identification technology, RFID. Now, when we need to write a few points about this, what exactly is RFID technology. You don't need to write rocket science, write very basic point. What it is a wireless communication technology. Everyone know this, using radio frequency. You don't technically need to write what exactly is radio frequency. Now, when it is working, you already whatever you know about this FASTag or how FASTag is working, you write about it. There is no physical contact. That is the key aspect of this RFID technology or FASTag. There you don't need to touch the car, or you don't need to get any to and fro things, that is transaction that is happening between the toll collector and the vehicle. So no physical contact. And what are the components? You have an RFID tag. You have an RFID tag. What is RFID tag? That is simply an QR code, similar to QR code like mechanism, and this is a passive one. What do you mean by passive? Passive means there is no inherent battery power, or inherent power is not there. It is powered, it is non-powered device, that is RFID tag. An active can have wider range. If it is passive, it is not having any inherent power, so it only works in a shorter range. You already know the car should be within few meters range of this camera, or that camera is the second component, that is RFID reader. Third component, you have this backend data processing system, software, hardware, cloud storage, internet, all of this. storage system. And what is the benefits, like key aspect of this? It completes all processing. Few seconds. This is basics aspect. See how I have generated the points. Mostly these all facts, is only if you think calmly you can generate these points. None of these facts has been superficial or something which you cannot do. All these are exactly what you already know. But you need that aptitude. Even if a question comes on LEDs, or even if a question comes on any everyday application technology, you need to sit calmly and write basic essential features of it. Simply what you know, what you see, you have written it in a consolidated manner, you will cover the subject. So RFID is the technology that is being used here. It has been mandatory on all national highways since February 2021. Then there is prepaid bank account linkages, all this kind of thing. And why this is significant? 70% of freight and consumer passenger traffic is happening through national highways. So if you can remember the data, if you can make a rough diagram, that will add more depth to your answers. What are the advantages of the technology? I'm not spending all my time on this part. Efficiency and time saving, and financial operation benefits. You can write about environmental benefits, digital benefits. You can write about fraud. There has been a lot of fraud happening in these toll centers. So these frauds has been checked as a mechanism to check the fraud. All these you can write. Limitations. What are the limitations of the technology? There are technical glitches. What if it's not working? What if connectivity problem is there? What is the software is not working? We see this in all digital India application, whether it is PDS, whether it is Aadhaar based payment system. In all aspects, there is always a possibility of technical glitches and the essential services not being provided to the necessary persons. Network dependency. What if the particular location in a pure connectivity area? Then how you are going to deal with this? There is issues with this. Implementation challenges, security, cost of concern. Then there is cyber attack concerns. There is attack from external aspects. Like you can write the Pahalgam attack, post-Pahalgam attack. What we have seen is post-Pahalgam attack, and when India was carrying out the Operation Sindhu, there was 1.5 million cyber attacks against Indian digital infrastructure. And even though we have a very robust system, 150 of these 1.5 million cyber attacks has been successful. They were able to get into our system. There is always a threat whenever the digital technology is coming into place. There is always a threat of cyber security, cyber aspects come into picture. And we can always cite the problem of data protection law, which is passed in 2024, and the implementation still lacks. There is a lot of more scope for implementation. Proper implementation is still happening in a haphazard manner, or not happening in a complete cohesive. Institutions and laws and practices are not still put into practice. Like if you compare the Indian data digital protection law and its current status with GDPR of European Union, we are still far behind. So these aspects again increases our vulnerability to the challenges. Now, what is the way forward? ANPR FASTag, that is the next upgradation of the FASTag, where you don't need to even like stop the vehicle. Automatic number plate recognition combined with existing FASTag. So you will have these cameras taking your number plate, and instead of this RFID, the number plates information will be sent from the number plate itself. So it makes things a little bit more faster, more barrier free. You don't even have to stop for the few seconds. You can have much faster access throughout. Again, when you write the significance of RFID FASTag, always write about improving India's logistics performance. What is India's current logistic cost? That is 14 to 15% of GDP, which is significantly higher. What we are trying to achieve is 8% of GDP cost. So this always should come into your picture. If it is not mentioned here, add it to your notes. whenever you get something value addition from the class or from outside, from new developments that is happening to the topics that is covered in this notes, you add those into your notes. This is how we go ahead. Now this is simply, we are just improving the ground technology. Now there is much more advanced topics in news. One is this GPS based or GNSS or Navic constellation based, GPS based system. What happens is, today when we suppose you are going from, say, toll collection happens at only specific points, and when you are entering, you are paying the whole road usage tax, whatever is the collection rate. Now if you are using only few kilometers, can you have the concession? This exact problem can be solved by having a GPS based. It will simply track when your vehicle is entering the national highway and when it is exiting. Based on how much kilometers you have used, it will charge you accordingly. Now this whole system needs the vehicles to have a global positioning system or a Navic installed into this. Now this is much better system, and there is other benefits associated with this. What is other benefits? There can be state surveillance, self policing applications, excise applications, tracking applications. All these will improve with this. Now this has a lot of benefits, but the problem with this is, if we are using GPS, which is a US based global positioning system, we are sending so much sensitive data to GPS. We are becoming highly reliant on a foreign technology. So what is government position on this? What government is saying that we will wait till Navic system is completely operational. We will wait till Navic system is matured. Only once Navic system is matured, then only we will go for this global positioning system based electronic toll collection system. This is another technology. Per kilometer billing, I have already told you. This can also be a particular application. Going ahead, rest you can read. I'm not reading each and every point. What is significant, I'm covering. Yeah, let's go ahead. Next topic, we have Digital India program. Again, there has been a lot of articles. If you are following the PIB or government, any of the government update websites, there has been consistent articles related to 11 years of government, 11 years of Digital India program, what Digital India program has given in last 10 years. So considering these, like, there is a lot of current editorials being written on this. Chidambaram have consistently written on these topics. What are the limitations of the government digital infrastructure? What are the benefits? And a lot of other editorials you can see on this particular topic. Very, very important theme for upcoming means, that is Digital India program. Now, whenever you are writing about, like what we spoke about RFID, you need to consolidate the basic facts related to RFID. Same goes with Digital India or any other government scheme is RAS. We have this UPSC have this trend of asking specific government schemes. We have question on Jal Shakti mission. We have question on other government schemes. Whenever this government scheme is asked, you should know basic facts related to it. What are the basic facts? Which is when it is launched? What is the key objective of this particular mission? Who is the implementing agency? These basic information. If there is any budget reference to this, then you should know. If there is any pillars, components to this particular scheme, then you should be aware of it. This much 3-4 dimensions you cannot miss out. See, Digital India program, it was launched on July 1, 2015. Again, you can see the significance. Today is July 1, 2025. Exactly 10 years from launch of Digital India program. So this again, even if it's a coincidence, it is UPSC has a question trend of picking these kind of topics when it is 10 years old, then you can expect a question from this. What is the vision? Transform India into a digitally empowered society and knowledge economy. These keywords should come into your paper. And how or when it will come into your paper? When you read this note and go for the examination. Otherwise, you will simply write that digital technology means implementing electronic technology into governance, into these aspects, and you write superficial answers and come back and you'll think that I have written great answers. No, it is not going to work. You have to exactly write what is the objective or vision of Digital India mission. Transform India into a digitally empowered society and knowledge economy. Write exact words. 3 pillars: digital infrastructure creation, digital delivery of services, and digital literacy. What are 9 components? Broadband highways, universal mobile access, public internet access, e-governance, e-kranti, information for all, electronics manufacturing, IT for jobs, early harvest programs. Even though 9 programs, it's remembering, it's very difficult. 3 pillars you should remember. Out of these 9 components, at least remember there are 9 components and list 1-2 components and write etc. That's how you can manage it. But 3 pillars, it is much easier to remember. So your answer should have the vision statement. Your answer should have dates. Your answer should have 3 pillars. Your answer should have, it has 9 components. Are you getting how you improve the quality of your answers? Current status: India is ranked 3rd in digital economy, digitization. India ranks 2nd in global internet users. India has more than 1 billion mobile subscribers. Use these data references, data points. Don't write answers like a school kid where there is no substantiation element. Spend a little bit more time to remember. Like if you can see, like when we are discussing the science and technology topics, we will come across a lot many data. And once you get used to this, you can, it is not like you read 5-point data and you can exactly only in this particular question you can use this. It should have cross applications. Like for example, like the most common data in this science and technology booklet or whatever science and technology related booklet you will find is India has low R&D spending. What is India's R&D spending? That comes around 0.6% of GDP. And compared to China, compared to say Korea or Israel, which spends more than 5%. We are considerably below in R&D spending. That is just 0.6 to 0.7%. Sometimes it's referred as 0.65% of GDP. Now, this particular data you will see across subjects. Whenever you have to write limitations of a particular technology, limitations of a government scheme, limitation of any XYZ technology expansion in India, you can use this particular in data. So similarly, then while we continuously go through material, we get used to many of these data. These kind of data points, your answer should reflect. And if it's not, your answer is not having enough data points, then again, don't expect 400 plus marks. Because everyone knows the peripheral story and you're not going to be rewarded for that. Let's go ahead. Again, a lot of other data is there. Some data may be a little bit irrelevant or you don't 130 crore other generated references. So you, based on whatever is relevant, you study some of these data. You don't need to remember exact each and every data. And many data like 5.67, even if you are not remembering 5.67, 5 plus crores, that will work. Simply write 5 plus functional community service centers, CSCs. That much of understanding is only expected from you. Budget allocation 782 crore, digital economy projected to cross 1 trillion. What is India's current economy size? That is somewhere between 4 to 5 trillion. So we are expecting 20% of our digital economy in current level to be contributed by digital aspects, digital technology, digital economical aspects. Future vision, Vikasit Bharat 2047. Again, Vikasit Bharat 2047. This is a recurring theme, not just in science and tech. Vikasit, spelling mistake, don't make spelling mistake. It's again very bad if you make spelling mistakes on these kind of things. Vikasit Bharat 2047. This is a recurring theme throughout your all GS papers, and you have to make references. Even in ethics, even in other papers, you have to make reference to this. What is our actual vision? economically speaking, what is our vision? Our vision is to have 30 trillion economy by 2047. Currently we are 4 to 5, so it is 6 times bigger economy by 2047. And currently we have a per capita income of say $2,600 per year per person. Now that is expected to be around 16 to 18,000 per person per year. This is our economic vision of Viksit Bharat 2047. Viksit Bharat has its dimensions for every specific sector. You can see download the Niti Aayog document and go through this. It has a vision or targets or numbers for each and every aspect of governance or economic aspects in India. So, but broad vision is this much. Again, when we speak about digital India, one thing you cannot miss out is UPI payments. And UPI already, it's expanded to 7 countries, including UAE, Singapore, Bhutan, Nepal, Sri Lanka, Wales, France, and Mauritius. So it's already expanded to 7 countries, and this is the base and strength of India's Digital India program or India's digital transformation. All these points you can bring into your answers. What are the benefits of this? E-governance impact, infrastructure development impact, financial inclusion, which you might be having some data also regarding this, and gender aspects. All these, then Jan Dhan accounts are in the name of women. Most of these functional accounts are in the name of women. People have improved savings due to this. All these benefits you can, economy points you can write here also. And when never limit your answers. This is again, even if a digital India program is asked in science and technology, your answers should not be completely science and tech. Your answer should have societal dimensions. Your answer should have economic dimensions. Your answer, many of the program like semiconductor, when we say there is rare earth elements coming into picture, there is diplomacy coming into picture. Your answer should have a dimension of international relations. And never hesitate from using these dimensions. These are like part and parcel of science and technology answer. Never limit your answers to only technology aspects. Nuclear technology, you have India-US relations. That is the crux why nuclear technology is in use. That is the crux why government came with ambitious targets in Union Budget 2025-26. Indian-US relations and ongoing negotiations, that is the basis for expand so many developments happening in India's nuclear sector. So your answers should also dig into how you can interconnect into other aspects, other subjects you are learning. Security aspects, suppose you are writing an answer on drones. Now, drones answer will be incomplete without writing about security aspects. Like we have seen during this India-Pakistan recent conflict, like how the attack has changed. Earlier, people has to came terrain difficulty, the surveillance difficulties, all these problems. Today, you don't need to send people to attack. Send drones, and you can say send drones like in continuous manners. There is very less losses. Even if drone doesn't work, then losses on your side can be minimized. So if you are writing about drones, it will be incomplete without writing about national security aspects related to this. So try to get the interconnections. Never limit your answers to only technological aspects. Now, Digital India program, how it helps farmers. You also have a farm tech, how technology is helping farmers in your syllabus. So these are cross linkages. Digital India Agriculture Mission, if you know some numbers, it will be more great. Then ENAM, you should write 1,000 mandis are already connected. 1.7 crore farmers are already making the use of this Kisan Suvidha app, which gives weather updates. You can download this app to have a feel of it if you want. M-Kisan portal, SMS-based farming advisories, digital crop survey, which is done using drones. Some programs like Namo, Didi drone scheme, where women are given funding assistance as well as training on using drones and these applications. So these kind of schemes you can cite. Challenges and concerns, again, 72% internet gap in gender gap in internet usage. 72% male are using internet, while 48% of rural males gender aspect is covered, as well as urban rural divide. All these aspect is being covered. Entry level smartphone limitations, internet limitations, you can see. Slow internet access compared to other countries. Like, how is India's internet ranking? India fares very badly. 93rd rank we have, with a speed of somewhere around 60 plus Mbps download speed. And say better countries like Singapore has India's 5.5 into times better speeds, somewhere around 330 Mbps. So we are in internet speed, even though if you speak about data, India is one of the places where the data rates are the lowest, but we are not so good in terms of internet speed. So this can be a limitations. One need for 1 million cyber attacks. We have already spoken about these cyber attacks. 1.5 million attacks. During or post Pahalgam. And out of these, 150 has been successful. Okay. There has been a meaty data breach where Indians' data has been available in dark web. All this information you can use in writing about the limitations of Digital India program. Rest of the trivial points you can read from here. Some schemes are given in budget 2025 references, like Bharatiya Bhasha Pustak scheme, where digital books in vernacular languages are stored or converted into digital form. Gyan Bharatam mission, where National Digital Repository of Indian Knowledge System is being developed. Broadband connectivity to all rural secondary schools and primary health centers. This has been given the targets in the budget 2025. Rural Digital India Inclusion Technology Advancement, Adult Innovation Mission, Adult Tinkering Labs, Aspirational Districts Program. So these kind of aspects, these are like fashionable, or you can say flagship government schemes. These should come reference in your answers when you're writing not just about Digital India program, but broadly whatever theme you are covering, your answer should have references to this. Going ahead, Samudrayan mission. Now we focus too much on ISRO. Sometimes we lose our focus on ISRO and space. We lose our focus on what's happening in the other side of the globe. And in that aspect, Samudrayan mission is quite important. And once in a while, once in 1 month, 2 months, you get one detailed explained page or editorial regarding Samudrayan mission, what exactly is happening. Some kind of experiments like Gaganyaan mission, if you look, every 1 month you get some kind of experimentation going on, and there is reference to these in newspapers. Same goes with Samudrayan mission. Some kind of experimentation is going on, and you need to have the basic premises. What is the mission components? Deep Ocean Mission, DOM. Nodal ministry is Ministry of Earth Science, and developer is National Institute of Ocean Technology, Chennai. 4,000 crore 5-year period mission. 2026 is the target. Manned submersive vehicle has been developed, Matsya 6000, which go to 6,000 meter depth. Depth capability of 6,000 meters. 3 people it will take. 12 hours normal operational. 96 hours is the emergency provisions. Fourth generation self-propelled submersible is being developed. Now, why we are interested in this tech, why we are particularly interested in going into deep oceans or being interested in what exactly below the oceans, is because of this guy, that is polymetallic nodules. Polymetallic nodules. And what exactly is these are like potato shaped rocks, you can say, or crystals, you can say, which is deposited in the below the ocean beds. And why we are interested in this? We are interested in this because of these guys. Because of 4 guys. MCCN. And most important resource from in these polymetallic nodules, that is manganese. Like you can see how much manganese is there. 92.6 million metric tons or million metric tons of manganese is there in this. Then we have copper, then we have cobalt and nickel, and a lot of other, like from prelims perspective there are a lot of other metals, but for mains perspective these 4 main elements we can extract. Even if we have in medium future, we may be able to commercially extract these metals from polymetallic nodules. So this is the importance of this deep ocean mission or India's Samudrayan mission. Why we are like too much interested in this? Because of this. Again, you can connect this with India's rare earth elements import dependence. There is scope, future scope, that it is not just limited to these 4 metals. There can be rare earth elements also. In particular areas, we haven't completed the complete resource mapping also. So this can give more opportunities in the future. So we need technology. If something happened in the future, we need the technology to leverage it. So that's why, again, significance of the Samudrayan mission. Current status, this is being developed. The budget allocation has been completed. Submersible integration is being successfully completed. Shallow water test is being going on. Unmanned test is planned for 2026. And manned mission is planned for end of 2026. What are the anticipated benefits? Again, blue economy, again data, which contributes to 6% of India's GDP. Resource segment assessment, 380 million tons of polymetallic nodules can be explored. Tourism potential, deep sea tourism development. Nickel, copper, MCCN, this is code mnemonic, you can remember this. Most important thing out of this is manganese. India has been allotted 75,000 kilometers square in central Indian Ocean bed. Strategic advantages, again, as we discussed, scientific advancement, oceanography, marine biology, club membership. Only US, Russia and China, France and Japan has this deep ocean submersible technology. So we will be considered part of this particular tech. Again, SDG 14, whenever you are writing SDGs, do mention that what exactly is SDG 14, otherwise it doesn't make any sense. What is SDG 14? Life below water. Challenges, environmental challenges, you can write high pressure, high darkness. There was some like Titanic, deep ocean tourism accident a couple of years back, so you can cite that incident. Then darkness is there, low temperatures are there, you have to, like, very extreme conditions you have to operate. Even if it is a manned division, it's as to the conditions that is put before you is extremely challenging or extremely, you can say, difficult. Operational risk is there, complex logistics is required, personal safety management is there. Rest of the points are trivial points, you can read from here. We will go to the next part. Again, achievements of Indians in science and technology. Again, this is a very next broad area. Cannot really complete this aspect related to this, but what you have to focus is whoever names are being given in this booklet, at least 5+ points you should have, specific points you should study on each and every scientist. All very big major names has been covered in this booklet, so you don't need to like search or collect from here and there. Broadly, whoever is relevant is being covered here. Yeah. So we'll start with Bose-Einstein condensate or Bose-Einstein statistics. Just refer to for the mathematics of this. Now, this has been a PYQ. 2018 PYQ was exactly this. If you look from a individual perspective, like why Bose-Einstein condensate is being asked, the technological aspect is being asked, it seems a very difficult question. But if you have studied 5 points regarding Satyendranath Bose, and you have at least have a fair understanding on this God's particle, Higgs boson, all these news are extensively in news. Some of the other developments, some of the other discoveries are happening. So these are extensively in news. If you read about something about, you are aware that Bose-Einstein condensate is there, and you are just fairly aware about the God's particle, what is happening, news, currently in news. So you will be getting at least 4 or 5 enough good points to complete this answer. Getting? This is how you treat that. Like, you should have a hold over the syllabus. If you have hold over the syllabus, even if it is a tough question, seemingly tough question come in the paper, you can still have content, you still have tools within you to handle that question. If you have missed out on this part, if you went to the exam hall without knowing specific details on Satyendranath Bose, then gone. You might not be able to even get 2 marks out of it. You will have to write something that comes into your mind, or you have to guess based on what can be Bose-Einstein condensate. Specific points will not come. Again, no marks, 2 marks, half marks. It's not going to help you, right? What exactly is this Bose-Einstein condensate? These are the recent developments. Recently, we have next topic, that is, we have an organization and there has been research funding given to Bose-Einstein condensate. There are different aspects of recent developments that is exactly going on in this field. That's why we have put this field here, question here. Now, what exactly is this Bose-Einstein condensate? This is nothing but 5th state of matter. What are the 4 state of matter? We have solid, liquid, gas. Everyone will be well aware of this. Then we have plasma. What is plasma? That is, here it is written, consists of, you can zooming it here. What is plasma? It consists of super energetic and super excited particles. These particles are in the form of ionized gases. The fluorescent tube, the neon sign bulbs consist of plasma. Inside the neon sign bulb, there is a neon gas which gets energized, which gets ionized and converted into plasma stage. So this is what is the 4th stage of matter. Now, this is the 5th guy, the 5th state of matter. What is 5th state of matter? Like Indian physicist Satyendranath Bose had done calculations for his 5th state of matter. Building on his calculation, Albert Einstein predicted a new state of matter which is called as Bose-Einstein condensate. In 2001, Eric Cornell, Wolfgang Ketterle, Carl E. Wieman of USA received Nobel Prize in Physics for achieving Bose-Einstein condensate. This is the premise of what is Bose-Einstein condensate. What exactly is this? What exactly is it? 5th state of matter. Atoms reach lowest possible energy levels, and at this lowest possible energy levels, this whole compound or whole structure act as a single atom. Single atom. And when it happens at temperatures as low as negative 273.15. That is also called as 0 Kelvin or absolute zero temperature. This is too much technical, you can skip it. Key properties: macroscopic quantum coherence happens, where quantum effects become visible at greater scales or larger scales. Zero viscosity, superfluidity comes into picture. Similar to superconductivity, superfluidity, the fluid characteristics become ideal. Matter wave interface become macroscopically apparent. Historic milestone, basic information you can. So you got the now applications. You got the basic premise. Even if this much of knowledge, this much of fundamental understanding you have on this, you can easily attempt this question. And applications is a guesswork. You have to think strategically, that's all. Applications is, and nobody can deny the applications, right? It's an upcoming technology. It's a quantum state technology. This much, if you are aware where it can be applied also, you can easily write it. But if you are not having this much of basic information, then you are in trouble. Then you cannot write a satisfactory answer for this question. Significance and potential applications like quantum computing, quantum simulation. Whenever you're writing quantum, write about China's quantum satellite. Now, precision measurement, encryption, communication, ultra-sensitive magnetometers, gravimeters, atomic clocks, advanced technology like atom lasers, matter wave circuits, light manipulation, nanotechnology applications. All these aspects can have, say, this applications of this particular aspect. What is Bose-Einstein content state? Bose metal, superfluidity we already discussed. Anti-stealth technology. Anti-stealth means non-registering in radar and other surveillance mechanisms. So it can have help in development of technologies which cannot be maybe not registered in these radar and other kind of aspects. Technical limitations I'm not going to discuss too much. You can go through the material, otherwise it becomes, our class length become too lengthy. You already have this access to this PDF, and our intention is also not to sit and teach you each and every point. My only intention is to give you an overview, to give you what are the key areas you should focus, to give you a broad understanding of the subject, so that when you revise this material, your works become much more easier. You can revise it much faster. And some of the key aspects, elements, which examples I use, key data I use, you get also registered in your answers, and you can use this in your answers. So this is our major objectives. It's not like we will teach you everything like foundation classes. That's not going to happen here. So these points you can read on your own. It's an establishment of ANRF, that is Anusantan National Research Foundation, which have replaced as CRB. So this is an organizational development. You can, direct questions may not be available for this, but you can use this as a sectoral development, use this as a India's, when we speak R&D is weak in India, this is what government is doing to promote R&D. They are reorganizing themselves. Their institutionalizational changes has been implemented, and this is one aspect regarding this. REST legal framework, all these kind of things, I'm leaving it to you. Go through this. These are basic aspects, government PIB document on what exactly is this scheme ANRF. These are some data facts. 50,000 crore over next 5 years for total funding. Government contribution will be 14,000, and private sector philanthropic raising will be 36,000 crores. 1 lakh crore corpus for low cost R&D loans. This is exactly what government is doing to increase the 5.6%, 65% R&D spending. Target is 2% of the GDP should be spent on R&D. India currently ranked 6th in patents, 3rd in global research publications, 3rd in research, 6th in patents. 3 lakh plus papers has been published in from India. Strategic areas, some here mnemonics, a lot of throughout the document you will find one or the other mnemonics. Just use the mnemonic strategic areas, which include climate change, health and agriculture, energy, semiconductor, science interfaces, quantum technologies, AI, cybersecurity, etc. Now, some of the renowned scientists, again, this is factual aspects, and going for the examination, you should know a few aspects related to this. There is nothing conceptual or too much to discuss. Few specific contributions of each and every scientist which is given in this booklet, you should be aware of it. That is only my intention in putting this part. Srinivasa Ramanujan, you can see some of the aspect, number theory, infinite series. What are his mathematical analysis? Partition functions, lot many, 3,900 results with mathematical formulas he has developed in his small time span. This is why we call him the man who knew infinity. Yeah. K3 surfaces, which is a contribution, mathematical contribution of Srinivasa Ramanujan. Again, pi formulas has been developed in as early as 1913, 1914. Now, the key aspect is we don't need to know all of these things. You're not asked what exactly is pi formula or K3 surfaces. But when you're writing about Srinivasa Ramanujan, at least 3 points from these should come into your answers. Rest of the points you can make up of your own, but at least 3 specific points should come into your answer sheet. Computational breakthroughs, collaborative works, all this you can go through the material. I'm not spending too much of time. CV Raman is very much important. Why? Tell me why. He may be the only physicist who worked in India and received Nobel Prize. Specifically physics. Now, this has happened way back. What was the year? Year I forgot. Nobel Peace Prize in 1930. Yeah. Got this in 1930. So it has been, say, 95 years since, or say 94 years since. We haven't got, none of our scientists has got Nobel Prize who has worked in India hasn't got any Nobel Prize, even though we have reached recommendations like Sir Rao, but none of Indian scientists got Nobel Prize. This has been why this is happening. Again, we have covered this in the later part, so when that part comes, we will discuss this. Otherwise, CV Raman, why he is famous? Raman effect. What exactly is Raman effect? When light passes through different materials of different diffractive index, then the wavelength of the light changes. Then that is exactly what is Raman effect. And this again has wide range of applications like Raman spectroscopy. The whole science of spectroscopy is based on this. Now, his other contributions, musical acoustics, like how he has done scientific study on veena, tabla, all these Indian cultural musical instruments. And what is the scientific basis for this? He has done his, can be considered as an extension of works of Panini in modern light. Rest of the points you can go through this. Institutional contributions. Again, when we speak about, say, CV Raman, or say speak about Homi Jahangir Baba or Sadish Dhawan, so your answer should have institutional contributions. These people, has contributed immensely to the institutional development of it. And what exactly are the Indian Journal of Physics, Indian Academy of Sciences, Current Science Association, at least one institute. If you can start in your answer, that's it. Jagadish Chandra Bose, JC Bose, he has a multi, like you can say, Da Vinci of India. No, that's my calling with. There is exactly no reference like that. Don't write in the examination. Jagadish Chandra Bose, he has wide sectoral analysis, you can say, wide sectoral applications, from wireless technologies, from radio technology to first semiconductor patent he was awarded in 1904, to microwave research, to radio wave detection, to plant physiology and biology. So he has developed creditor for the invention of crescograph, which like monitors the growth of the plants and to the scale of 1 to 1 lakh of an inch. That much minute growth of the plant can be monitored or examined or studied using this crescograph, whose invention is credited to JC Bose. Institutional building, again, as I told, at least one institute you should remember in the examination. Recognition and legacy, you can go through this. M. Vishweshwaraya, again, this is a PYQ. Engineering applications. Krishna Raja Sagar Dam, this is the greatest achievement. He was the chief engineer for the construction of this particular dam, which is built over Kaveri in 1924. Automatic floodgates or water floodgate system. This has been implemented in multiple dams across in India, and its invention development has been credited to Sir M. Vishweshwaraya. Block system of irrigation, which has been developed, or you can say implemented across Deccan. Flood protection systems in Hyderabad, the other cities, these all are being credited to Sir M. Vishweshwaraya. Founded then institutional contributions, founded engineering institutions like Government Engineering College in Bangalore in 1917. University of Vishweshwaraya College of Engineering has been named in his honor. Industrial modernization, he has been member of Indian Planning Vishweshwaraya Plan, which is quite famous. Rest of the aspects you can read here. Prashant, the PC Mahanapolis, again, something which is directly picked from the newspapers. Why? Because what is the date? 29 June. 29 June is National Statistics Day, just a couple of days back. And why, on what remembrance of what we are celebrating the National Statistical Day? That is the birth date of none other than PC Mahanapolis. What are his contributions? What are his geographical analysis, institutional contribution, like Indian Statistical Institute has been founded. The Sankhya, that is the Indian Journal of Statistics, has been founded in 1933. Economic planning, organizational building, he was a member of Planning Commission, you may be well aware of. Which 5-year plan has been named on PC Mahanapolis? Second 5-year plan. And what was the focus? That was heavy industrialization. Blueprint for industrialization, heavy industry development. It was based on this industry we got these power plants, which has been power plant technology. Big dams have been established in different parts of Bakranangal Dam. All these dams plan has came from this Mahanapolis second 5-year plan. All these aspects you can bring into. Anthropometry, he has also contributions. Flood data analysis, also he has contributions. Father of statistics in India, he is also called. Satyendranath Bose, again we have discussed a little bit of him when we were speaking about the Bose-Einstein condensate God particle. He is also called as the father of God's particle. And what exactly is God's particle? This part, again, you read on your own. I am not spending too much of my time on these particular aspects. What exactly is God's particle? Again, particle physics, or you can say the basic particle physics. For prelims, it's very important. Consistently, we have got questions from this. From mains, hardly any questions. So it's not too much of importance. But again, being said, you cannot completely neglect it. Sometimes a question can come. because newspaper every now and then we have recent developments regarding this, and India is also active contributor of this Large Hadron Collider. We are contributing the condensation of this refrigeration system in this. So there has been news articles, there has been recent developments, and it is something which is actively followed by UPSC in prelims. There, even though it is not asked till now in mains, you cannot neglect the topic. You should have a brief understanding on what and why exactly is this. Again, it's reference with reference to our Satyendranath Bose or Bose-Einstein condensate. What exactly is Gold's particle? Gold's particles are bosons, specifically Higgs boson. And what exactly is Higgs boson? All these references or these particles like Higgs boson, fermions, photons. Which model? This is the standard model of universe. Standard model of universe. Basic understanding you should be having about this. How this model describes universe. It describes fundamental building blocks of force through their interaction. What are the fundamental forces? We have 4 fundamental forces, right? Out of these 4 forces, 3 out of these 4 forces is being explained by the standard model of universe. And which force is not being explained? That is not gravity. Cannot explain gravity. Rest of the forces it can explain. Now, what exactly are bosons? Bosons and fermions. These are 2 subatomic particles from standard model. Bosons have an integer spin. That means its spin will be 0, 1, 2, etc. Fermion will be half integer spin. Its spin will be half, 3 by 2, etc. Now, what exactly boson does? And what is Bose-Einstein statistics? That explain the mathematics of these bosons. And what exactly these bosons are of different types. What are these types? These types, the most important one is photons. And what is photons exactly? Photons are carriers of electromagnetic force. Then we have gluon. What are gluon? Gluon are carriers of strong nuclear force. Third, we have W and Z boson, which is carriers of weak nuclear force. And fourth type of boson, that is Higgs boson. Higgs boson. And what exactly is this? It gives mass. It explains the formation of mass in the universe. And whatever the visible universe we are aware of is somewhere connected to mass. That's why we given it the name the Quartz particles. So this is the basic understanding. What is the role of bosons? Again, it's a force carriers, mass generation, condensed matter. So these all points you can use in Bose-Einstein statistics to some extent also. So this is a very narrow and over the view understanding of standard model of the universe. And question can come on this because there has been a lot of recent developments regarding this. Rest of the, if you have this much of understanding, what is written in this booklet is just factual content. You can go through these materials. And I'm not spending my time on here. What is Indian contributions? What is India doing? What is the world doing? What exactly is happening? Way forward, significance, everything is covered. We have consolidated all these developments into this one-page note for you. Then Homi Jahangir Baba, continuing our references to Indian achievements. We have Homi Jahangir Baba, Baba scattering, Baba Hitler theory, Meson research, nuclear physics contributions, institutional TIFR, atomic energy establishment, atomic energy commission, three-stage India's nuclear program. What exactly is India's three-stage nuclear program? Fair understanding. This all has been conceptualized by Homi Jahangir Baba. What is first stage? Should have fair understanding of these also. Again, nuclear technology from a lot of aspects is very, very important for this mains examination. What is India's three-page program? The first stage is pressurized heavy water reactors. Pressurized heavy waters, what it uses the fuel is uranium-238. Now it is subjected to nuclear fission and we get energy, plus plutonium-239. Now this energy we use for electricity or whatever. And why it is called heavy water? Because D2O, that is deuterium oxide. Deuterium is isotope of hydrogen. It is used as moderator. What is the function of moderator? To slow down the neutrons. So this is the stage 1 aspect. Stage 2. Stage 2 is called as fast breeder reactors. Now fast breeder reactors, if you remember, why all these stages are connected, right? Why they are connected? Because nuclear waste management is a big threat. What exactly we do with the nuclear waste? We are currently digging deep into deep zones and storing it there. But how much sustainable is that, or how long we can continue this practice? There has been questions on all of this. So our program has been designed with this point in mind, that we need to minimize the nuclear waste. So this is the fair version of this. So second stage reactor, it uses uranium-238, which is naturally available, plus the plutonium-239 from above nuclear reactor. This will again form energy and more plutonium. So it produces more fuel than it consumes. We have recently the 500 megawatt plant at Kalpakkam has been functional, achieved criticality for this second stage. Now third stage is an ambitious stage. So there has been no functional plans based on the third stage. And what exactly is the third stage? What is third stage? Thorium based reactors. It uses uranium-233, is enriched uranium, and thorium-232. This will give us energy. Why India is too much interested in thorium based reactors? Because we have this black sand. We have huge reserves of thorium in Kerala coast, in Andhra coast. All these are like rich reserves of thorium reserves India is having in the form of black sand. So that's why India is too much interested in thorium. Again, for uranium, if you speak, we are dependent on Australia. We are having deal with Kazakhstan. We are also having deal with Russia. So we are looking dependent, too much dependent. Resource constraints we are having if we speak on uranium. But for thorium, we are blessed with huge resources and we don't need to look at other countries. But this technology is not matured, and in future maybe, yeah. Vikram Sarabhai, you can read it from here. I'm not spending too much of time regarding this. ISRO, it was established in 1962 as INCOSPER, then later it becomes ISRO as we know today. India's first satellite, Aryabhatta. These has all been contributions of Vikram Sarabhai. Then Satish Dhawan we have covered. Then lastly APJ Abdul Kalam, which you should never miss. Some of the specific technological contributions of APJ Abdul Kalam, including small satellite, India's first satellite launch vehicle, PSLV, GSLV developments, missile ban of India because of India's guided missile program, directed Project Devil, directed Project Valiant. He has been main role in Pokhran 2, that is the nuclear experiment India conducted in 1998. All these aspects, at least few technological contributions of Sir APJ Abdul Kalam, you should be well aware of. Why Indians are not getting Nobel Prize? Are we not good enough? These points has been covered here. C.V. Raman in 1930 got it. It's been 94, 95 years, and none of the Indian scientists, means Indian origin scientists working in US has got Nobel Prize, but none of the Indian scientists working in India has received Nobel Prize. Why now? Funding crisis. R&D is 0.6 to 0.7% of GDP. USA spent 2.7%. Israel spent 4.9%. South Korea spent 4%. 600% lower funding than South Korea India is having. So we have a very research and development infrastructure. Researcher problem 5 into fewer researchers per capita versus global average. So on total, we are spending less. Now, how much we are spending on each scientist or each researcher, that is 5 times lesser than the global average. So again, talent pool problem, limited cutting edge research institutions. Again, here you can write about, private sector. If you look at the major global institutions, like especially in US, the US Institute, MITs, or any other Wharton or US Ivy League institutions, all these are not completely state funded. There is a very strong alumni system working. There is very strong private system through industry, academia linkages. All these aspects, we are not strong enough. These are not our strongholds. Most of our league institutions, Ivy League similar institutions like IITs or ISC or say IIMs, where these are coming from? These are coming from completely state supported, state funded. Our network is still very weak. Bureaucratic barriers, the time span for ordering equipments, 150 crore GST notice to IIT Delhi, government e-marketplace delays, tap innovation, corruption, all these aspects. Research focus issues, insufficient basic research emphasis. Again, India, the focus is on filing patent. The focus is never on commercialization. This is why we can see, even though India is 6th largest country in filing patents, how much of these patents are becoming commercialized? It's very meager. It's something numbers you can count in fingers, that much low it is. Why? Because our institutional focus or our focus of our academic system, that is on filing the number of patents as an academic achievement. We're not focusing on the usability. We are not focusing on the application of these particular patents. Infrastructure gaps. Bottom line, systemic deficit, systemic underfunding, bureaucratic problems, small research base, all these contributed to these 94, 95 years. No Nobel Prize for India. Indigenization of technology, again we had direct PYQ from this. Again, this is in news because government is so much interested in it. Atmanirbhar Bharat. So all these aspects, indigenization of technology, directly the keyword is given in the syllabus also. So you should be decently aware of what are the context of this particular subject, topic. What is definition? developing local capabilities to design, manufacture, maintain equipment using domestic skills or resources. That is basic definition. Goes beyond manufacturing from foreign drawings and requires understanding of underlying technology modifications. So means basic sciences are involved. Part of Atmanirbhar Bharat initiative, self-reliance program. Recent developments, defense sector. Defense sector exports, or as well as defense sector indigenization, should write something again specific. Tejas fighter, BrahMos, INS Vikrant, DRDO radar systems, Arjun tanks. Only if these names you have written, then only it makes sense. And when we speak about defense, you should write about the India's defense. This is more focus in internal security, but since we are covering the topic, defense exports, so much in news. When you're writing about these names, Tejas, BrahMos, INS Vikrant, DRDO radar system, Arjun tank, all this should come into your answer writing. Now, defense exports. Here you can make graph. Here you have export data. Here you have year. In 2013-14. 2013-14. Indian defense exports was, say, less than 600, around 600 crore. By 2023-24, we have reached up to 21,000 crore. Now we are expecting it to increase to, by 2028-29, we are expecting it to increase to 50,000 crore. So you can make this diagram, 2 data points if you have, you can make the diagram. So this is another way you can have brownie points, another way you can impress the examiner, another way you can add one more point into your otherwise generic answer. So these things you should be well aware of. Again, space technology and indigenization, then you should be well aware of ISRO. And when we speak about ISRO, ISRO has specific advantage in low cost launches. Low cost launches, how much is our capability? We have our lowest cost, that is small satellite launch vehicle, which cost just 4 million per launch. Compare this with SpaceX Falcon 9. Even though there is difference in the size or capacity of the rocket, still it cost around 65 million US dollars per launch. You can see we can do 15 launches compared to the price of one Falcon 9 rocket launch. You can see the difference. So when we speak about low cost advantage for ISRO, should cite these numbers. When we speak something about defense exports, you should cite these numbers. Otherwise, there is no absolute point. UPI, we already covered too much. You already know so much data. PLI scheme, semiconductor, all these we are going to discuss in detail. So this is more like a generic point. Indigenization of technology, if it is asked in general, then there is no dearth of points. You can literally include any XYZ technology, from quantum science to supercomputing missions to India's space defense, or India's even traditional knowledge-based biotech programs. All these aspects can be brought into picture. Digital tech, most importantly, you should not miss that. Again, the 0.7, 0.6%, the skill gap of 30 to 32 million people, 95% of semiconductors, 90% of semiconductors are imported from different countries. All these aspects would come part of your answer. Key aspects in budget related development. So how much is the allocation for science and technology? All this aspect, 20,000 crore allotted to research, development, innovation initiative, deep tech fund. Anyway, there is a possibility of asking in examination what exactly is deep tech. What exactly is deep tech? Which are companies which are making solutions based on scientific discoveries, new scientific discoveries, or new engineering solutions. This includes widely all the upcoming technologies like AI, like blockchain, like quantum science, like metaverse, like cyber related aspects, and so on and so forth. This is very generic definition of deep tech. Rest, if a question come on deep tech, what are the possibilities, applications, challenges, way forward, government schemes, these you don't need to worry about. Whatever the points we have accumulating through this session, you can use the same points in the, and a lot of other government schemes are provided here. Nuclear energy mission we will discuss in detail as we go ahead. Rest, you can go through this document. India's nuclear energy plans. This is too much in news, and there is a real high possibility this can be asked for this means. And what your answer should include is the many basic data points. What is India's current nuclear capacity in 2025? Again, you can make a graph of this. Our nuclear capacity is 8180 megawatts. And what we are expecting is, what we are projecting or 2031, or our target is to by 2031-32 to have a capacity of 22,480 megawatts. And this again an ambitious target of under Vikasit Bharat 2047 to have a target of say 100 gigawatt by nuclear energy. This is India's targets, and this will be also supplemented by a 5 small modular reactor by 2033. This is our medium term and long term nuclear targets. Question came on nuclear aspects. Your answer again should include these aspects. Otherwise, it's an incomplete, insufficient answer. Now, what are the recent developments that is happening in this sector? Key initiatives: Bharat Small Reactor. We'll see what exactly is the Bharat Small Reactor. Nuclear energy mission for Vikasit Bharat, which is having these targets as we have explained right now. India's 3-stage nuclear program. We already have a fair understanding of this, and this is India's energy Vikasit Bharat targets. Current limitations, like why we are discussing all of this, why nuclear energy is particularly important for this year, is because of the negotiation happening between India and US, and US companies are in a mood to invest in India's nuclear development programs. But there are certain limitations within our, like what we have done in space. We have and other institutional mechanism put in place to support this private sector participation in space tech. And this has gained a lot of positive improvements. And what we are trying to do is we are trying to replicate these developments in nuclear tech. We are trying to promote the participation of private sector in nuclear tech, which includes both the private sector within Indian base, the private sector from other countries, especially in the context of United States. This is the premise of why nuclear energy is important. And what are the issues? There are certain issues which directly prevent private sector from participation in nuclear sector. And what are these issues? That is Atomic Energy Act 1962 provisions, which include prohibits, direct section 14 of this particular act prohibits private entities from obtaining nuclear licenses, restricts to central government departments and government companies only. Supreme Court upheld the constitutional validity of this in 2000, this year itself, in this Sandeep TS versus Union of India case. Again, Civil Liability for Nuclear Damage Act, which have an operator liability cap of 1500 crores. And again, a government liability cap of 2100 to 2300 crore. Now, one set of argument is this is limited. Comparing, if you compared with the magnitude of losses that happens during a nuclear threat or a nuclear accident, then this 1500 crore is too less an amount for compensation, and you are capping it for government as well as capping it for the supplier, then operator, then it is having certain issues. Section 17B of this particular act, unlimited supplier liability. So this is again demotivating, especially foreign companies. Companies like Westinghouse, why it doesn't invested in, if you look at how India's civil nuclear program has transformed, like after the Pokhran in 1998, this was a nuclear experiment India conducted. And what was the response? United States acted very, very strongly against India. They came up with sanctions against India. Now, these sanctions put all kind of nuclear dealings for other countries. They're prohibited from dealing nuclear aspects with India. Now, these sanctions were in place in early 2000s. Now, this whole changed by the 123 agreement in, say, 2008. 123 agreement, US came forward and signed a treaty with India, which was a watershed moment in India's civil nuclear development. And under this treaty, even though India is not a NPT, Non-Proliferation Treaty member, there has been special consideration given to India. Under this, the US is ready to have collaborations, have transfer technology, have nuclear power plants given to India on civil nuclear programs. This was a watershed moment because this opened the gates for India's civil nuclear cooperation with not just US, other countries like Russia and France and a lot of other countries, like Kudankulam plant is developed by Russia, and some of the plants like Jadpur, something like that is developed by France. So India has nuclear deals with the civil nuclear deals with this country, and today India even have civil nuclear deals with Japan, which was very reluctant to deal with a country which is having not signed NPT, or safety concerns are always on the line. This is India's premise. And if you look back, despite US being the first nation to come about the sanctions and signing the deal with India, nuclear deal with India, US companies doesn't have their footing on India's civil nuclear programs. It is the Russians or it is the French that made use of these changed global stance. US were missed out of the plans mainly because of India's restrictive laws, which have these liability concerns, which have these restricted private sector participation. Now, this is where India is trying to make the changes, and this is where today US companies are showing their interest to expand dealings with India. So in this context, this becomes more and more important. So this is the context, this is the dimensions, the key points. Some companies like Westinghouse, it's a very famous company, you might be well aware of. Proposed atomic energy legislations, some of the legislation you should be well aware of. What are the issues we have discussed? Now, what are the proposals means? It would be something to expand, open up the sector and remove the above said liability concerns. Nuclear fusion, you can go through this, nothing much. For nuclear fusion, a bigger nucleus split into smaller nucleus, like we have seen India's nuclear energy program, where uranium was split into plutonium and some other elements, and this again split into two other, plutonium and say uranium-233. In fusion, the opposite happens. For lighter nucleus like deuterium and tritium, they under high temperature, high pressure, extreme conditions, their nucleus come too close so that they combine together to form a like heavier atom like helium, and in this process energy is released, is equal to mc square, the famous Einstein equation. On the basis of this, the lost mass will be converted into energy, and this energy is what, this process is what happening in the suns. This process is through which the whole metals or the atoms we see today has been formed. This is the overall construct of this. Recent developments, these India's budget allocations. Again, one very important thing I missed, that is what exactly I have told. I will explain this. Like BSR, we have Bharat reactor, Bharat small reactor, versus we have SMR, that is small modular reactor. So both these things are in news, and both these things at some places some people use this interchangeably also, but these are not the same thing. Small modular reactor, this is a new tech, and this use diverse technologies. This can use pressurized heavy water reactors, this can use free breeder reactors, this can use molten salt models. And here what is the critical point? That is modularity. That is, you are not just building the whole model, you are building different parts of it in different parts and bringing it together and assembling it, making a nuclear power plant. So this is the speciality of small modular reactors, and due to this modularity it can be transported. Normal nuclear plants, you fix it at a place, it will stay there, but there is possibility of transportation. This gives a lot of flexibility where it should be installed, power, how much power it should be installed, mostly revolving around 300 megawatt. This is small modular reactor. Around 150 plus designs in current world are available, and only 2 or 3 working reactors are there. So this is the whole construct of small modular reactor. Here the whole focus is on modular, and so as a technology, this is an evolving technology. This is an upcoming technology. What is India's targets? To have 5 working small modular reactors by 2033. Now Bharat reactors, Bharat small reactors, these are not new tech. These are 220 megawatt pressurized heavy water reactors. This is exactly what is our stage 1 reactor, stage 1 of our nuclear program. This exact technology is being used here. Only thing is, it is used for wider applications. How this is made possible? That is by reducing the size. Here the focus is size which is only 220 megawatt. Wider applications, what all it include, like captive power plant in some industries, chemical industries, or cement industries, or other XYZ cement industries. All these industries where there is huge demand of electric power, you can use nuclear power plant as a captive power plant. Earlier it was not possible. These are bigger plants, and there was size limitation, science constraints, and other aspects. So this is being overcome due to the smaller size. So here what is important in Bharat small reactor, the size small, that is the more important. So it can have not just electricity, heating applications, NPCIL can even operate this also. This is the overall construct of Bharat small reactor, whose size is the important thing. 220 megawatt is our size, and it is not a new technology. India's first stage reactor, that is pressurized heavy water reactors, is being used here. In case of small modular reactors, these are new tech. These are new designs. Even though the fundamental technology is the same, these are new designs, and it is an evolving technology. This is only 3 models are there. 150 plus models has been floating around in the world. So this is a diverse new technology. It uses also diverse technology, not just pressurized or heavy water reactors. So yeah, this is comparison between BSR and SMR. Rest you can go through these. I'm not spending too much of my time on this. Comparison between nuclear fusion and fission. The greatest advantage of fusion is it doesn't have these harmful emissions. Nuclear emissions are not there in nuclear fusion. That is, and other advantages exist like 4 into more energy density, no chain reaction, harmless helium is the byproduct, deuterium, tritium is the fuel. All these substantial advantages is there, but the technology to implement as such is very difficult because it only operates at extremely high temperatures and pressures, which is we have material constraints, we have other constraints to sustain these nuclear fusion reactions. Many times we need to spend more energy into this rather than the energy that we obtain out of the nuclear fusion that is happening. Now, different benefits: energy efficiency. This some mnemonics are also given: zero principle, SALT framework, safe concept. Even though when you're reading it first time, you will think what exactly is this, but go through this on a regular basis. Go through this a couple of times, then you can be in a position to implement this in your exam. Challenges, technical challenges: high temperature, extreme temperatures of 100 million degrees Celsius, extreme pressure conditions, tritium, breeding, handling, all these kind of issues you can write about. Material issues I already spoken about. Cost and timeline constraint. Again, the most optimistic plan is having a feasible working plan by 2060. This is again optimistic, highly optimistic plan. It can, some plans have plans up to 200 to 100 and all. So that's a technological maturity. There is a hell lot of difference between where is nuclear fusion and where is nuclear fission. And something you should be aware of: what is the recent developments that is going on. Projects like ITER, India is also a part of these. Project like BARC, researchers done in India. So these aspects also should come in a part of your answer. Yeah, let's go to the next part, that is Semicon India program. So what exactly is Semicon India program? Again, basic facts you should be very well aware of. There is no scope of missing in this. It is a Semicon India program. It was launched in December 15, 2021, at least 2021 you should remember, with a budgetary allocation of 76,000 crore. What is the objective? Develop comprehensive semiconductor and display manufacturing ecosystem. Coverage: silicon fabs, display fabs. These are the components of the scheme. Compound semiconductor, ATMT, OSAT design companies. That means chip design is what is being talked about. Semiconductor India program, other details you can go through is, what I really want to discuss is India semiconductor industry. India semiconductor industry. Now, the problem with this industry is it is 90% import dependent. And if you look at the semiconductor supply chain, this is highly concentrated. Out of this 90% import dependence, 1/3 come from China. Rest come from Taiwan, South Korea. So a couple of countries are having super stronghold. Why India is having too much dependence, import dependence in semiconductors? Because what is the reason? Because of lack of domestic fabrication facilities. We recently have some research facilities. We recently have some facilities under this Foxconn deal. Before that, we doesn't have any fabrication facilities available in India. We have problem with raw materials. China is blessed with rare earth metals. That is why it is so aggressive in militarization of its hold over these rare earth metals. You might have read in news, China is stopping its export of rare earth metals to US, which will definitely crumble these R&D, fabrication industry, NVIDIA, all these guys that is operating from US. So India also has these raw materials issues, especially rare earth metals, where again 90% of India's rare earth metals is coming from China. Third, we have tech barrier. We have this whole industry is a high capital investment. Again, with our 0.6% R&D, we are not able to do anything. We have skill gap. Again, numbers 32 million. Manpower gap we already have in India. Concentrated supply chain, which I talked about. Yeah. And there is a diplomatic aspect of India is trying to acquire this lithium labs in Chile, in Argentina, this lithium triangle area. So there is in Africa as well as South America, there is diplomatic competition going on to acquire the resources in especially the third and poorer countries, third world and poorer countries. And you can write all trivial points like a R&D gap, 0.6%, all these kind of things are also very much relevant here. So this is why we don't have any semiconductor. We have issues with our semiconductor industrial base. And what exactly government is doing, that is the India Semicon program, and that has been in detail provided in your booklet. So I'm not spending future targets, some numbers, data, future predictions, significance, economic impact, technological leadership, all these aspects you can bring into diplomatic aspects, challenges, what are the issues, you can connect with whatever the issues we have discussed. National supercomputing mission, again, highly factual. There is no too much too conceptual to sit and teach you. You go through the mission, some core details, then current status, what it is, challenges, way forward, all these guys, you guys go through this. On that note, we will take a break here, then we will continue. Welcome back. So we will continue our discussion. So yeah, we have just completed the Indian major scientists, and yeah, recently next topic what we have is awareness in the field of, like, this is a long list that is given in your UPSC syllabus. What we have done, we have clubbed the similar topics and covered those themes together. Like we have clubbed the IT, computers, robotics together. And if you see from this section, most of the questions have been from developments in the IT, like new technology like metaverse and all other different technologies. IT related developments has been a frequent topic from where questions are being asked. Again, we have clubbed the nanotechnology, quantum science. Then we have the theme on space technology. Then a special section for biotechnology. Then we have issues related to intellectual property rights. So this is how the rest of the session have been, how it is being designed or planned. So let's start with awareness in the fields of IT, computers, and robotics. Yeah, first is sodium ion battery. We will slightly speed up, like we're taking quite a lot of time. So what we will essentially do is we will try to cover it in a little bit of faster manner. So again, sodium ion battery, this is highly factual tech topic. So this you can refer from the material PDF, you can refer this. Not spending too much time explaining what exactly is the tech, what exactly. Here is a comparison between sodium ion and lithium ion technologies given. This you can see here there are specific advantages for sodium. Why exactly we are interested in sodium? Because again, this is due to the resource constraint. lithium is not a very abundant metal, and even if we look at India doesn't have any viable lithium reserves. On the other hand, sodium, that is a highly very common sodium. It is in salt, common salt, and it is quite easily available throughout the world. So this is the major interest why the world is looking for alternatives to the lithium ion battery. There are a lot of other battery tech also coming up. We have also provided you a glimpse of what are the upcoming technologies in battery. More importantly, what I want to focus is in the battery sector. What is the sectoral aspects? Like if you look at India, again our classic diagram, you can draw a map, draw a graph out of this. 2025 we have a battery market of 10 billion US dollars. What we are expecting by 2033 is this market to expand to $25 billion. That is at least 2.5 into expansion in next 7-8 years. So this is what our expectations, this is of battery sector in India. And this major growth will be led by electric vehicles. Already we are making big strides in this. In 2024, we have already sold 2 million EVs, electric vehicles. So this is the overall context of battery sector. Rest the numbers, data, the growth potential, global aspects, Indian market potential, all this is given here. What is the projected growth? All these are covered, like electric vehicle battery demand, and like there is mnemonics like 4D. Why electric battery is becoming a hot topic in the near future? Because every upcoming aspects, whether it be decarbonization, 4D, what we call it, digitization, diversification of energy, democratization of EV adoption, energy sources, all these requires battery infrastructure setup, and the demand for storage, electric storage, is always on rise. Even renewable energy transition, decarbonization, like where the transition is happening. Even if we look at Indian scenario, the major growth in the last decade, or say last couple of years, all these major strides are being done in the solar energy. And what is the biggest problem of solar energy? That is intermittency. That means night you cannot have solar panels, it will not give you any power. So if you connect it to the grid, there will be huge variation. In morning you will be having huge power, in night there will be zero power. So how to balance this? Now we are not facing these issues because our grid connectivity is still of these renewables or solar energy is still in a manageable limit. But when nations by future, when we completely transition to solar based systems, then this is going to be a much bigger problem of a much bigger scale than what we are seeing today. So this is something we need to look forward to, like how to address this. And here again the solution comes in. We can have a base power plant, and base plant again has its limitations. So the second best alternative, always there should be a bankable battery system, even though it is not powering the whole city, but battery system demands is in context, even if it is in the context renewables or diversification or whatever it is, like democratization or digitization, all these aspects, battery demand is going to. Energy security, air pollution aspects, electric vehicles, why it is marketed as the cleaner source of fuel. Battery technologies, currently lithium ion is the market leader. In automobiles especially, we have these low cost lead acid batteries, then we have manganese phosphate variants. Some upcoming technologies, smart technologies like solid state, metal alternatives, advanced. In metal alternatives we have the sodium ion battery, which we have discussed earlier, recycling innovation, tungsten, and all these. And so much details is not required, but at least you should be well aware of what exactly is happening. Challenges before India: China dependency, again 75% of the imports from China, 84% from, if you include Hong Kong also, into China. Raw materials limited, lithium, cobalt, again cobalt, You have seen this in polymetallic nodules. So this is how you connect Samudrayan to here. Infrastructure, testing facilities, lack of skilled manpower. Kitna? How much? 32 million skill gap. Execution gap, PLI schemes, low progress, bureaucratic issues, red tape, corruption, all these aspects comes into picture. Surge, demand surge, which is leading to import surge. Cost burden, 40 to 50% of electric vehicle cost is from battery. And it has to be replaced after say 7 years maximum. Again, this is something why people has an aversion to go into this electric vehicle sector compared to the crude petrol or diesel vehicles. Government schemes, you should have a fair idea what are the government schemes. The FAME scheme we have. Currently FAME 2.0 is going on. Then we have PLI scheme, especially for batteries, 18,100 crore. We have a target of 50 gigawatt hour of battery production by 2030. Again, viability gap funding scheme. We have then some exceptions like duties and other exceptions, support programs like Make in India, Critical Mineral Mission, etc. etc. And diplomacy like Critical Mineral Partnership, all these IPEF, all these again diplomacy come to picture. All this also becomes a part of this answer when you are writing a problem answer on this battery segment or a battery sector. Budget 2025, certain implications that is being provided here. Leader strategy, that is a mnemonics again for understanding the way forward. You can go through this. I'm not spending all my time here. Let's go to the next very relevant and common and broad topic, that is artificial intelligence. Now, definition. What is AI definition? Whenever you are defining something, the strategy is to keep it as simple as possible. You can always use references. Certain organizations, terrorism, we explain in terms of, say, UN or UN terrorism organization, etc. The money laundering, we explain in terms of FATF or our PMLA Act. Similarly, like when you can give references, but the more important part is to keep it simple. What is artificial intelligence? Artificial intelligence is nothing but having human intelligence simulations or capabilities in machines. This is exactly what is artificial intelligence. Now, this is, you using better English, you have see the definition here, and whenever you question, sometimes the question asks what is artificial intelligence or what is XYZ thing, then there will be other questions of it. In that question, you may be thinking that I just made a very simple, like oversimplified definition. If you have such concerns, what is to do? Key features. Just had a key features, like here we have natural language processing, large language models, machine learning, expert systems, robotics integration. So all these are key features of artificial intelligence. So just add this part also, then your answer look comprehensive. If the question is what exactly is this technology, you don't want to write a 2-line definition like an intro type and leave it there, then just add features, components, any of these into this, then that will sufficiently have enough content to explain the XYZ concept. Baki data, you can go through this. 75% of the organizations or companies throughout the world is already using ROI, AI in their operations. Now there is another concept of artificial general intelligence. How is artificial general intelligence different from artificial intelligence? In AI of the current form, we are task-based. We are task-based. Now, what AGI do is it expands from task basis to the next level, that is independent decision making. Now AI is not capable of decision making, is not in its ambit. Its ambit is narrow. We define a very specific task that only the AI, whichever AI you are using, even in for content development, you give a very specific query, that query only it can handle, right? It cannot look beyond what you have asked. It cannot decide for you. For example, you need to design a card. You can write AI to design a card. Then it will show you some of the designs, some image generated through AI. It will show some of the designs. Now, what artificial general intelligence does is, when you say like design me a card, it not just design the image version. It will also look at online where which seller can provide you this and what is your most cost effective way, and it decides and place the order and get the card delivered to you. So placing the order, there is a decision making, there is an independent decision making happening there. AGI is complete simulation of human intelligence into machines. Artificial intelligence is more specific, narrow, task based. AGI is more broad. AGI is more independent. Decision making is also like coming into the construct of artificial intelligence. Some data predictions, and there is a global race going on between, say, OpenAI or Metaverse and other XYZ Google companies to get master this artificial general intelligence. This is an ongoing race between these top AI companies. What are the opportunities? 15.7 trillion economy. That is what the anticipated AI economy. Impact, net impact is assumed to be 20 trillion US dollar. This is the market depth which we are talking about. So again, when you write about opportunities for India, do include these data. Now industry application, there is mnemonics has me given, can go through this. Job market, other aspects is given here. Challenges, technical issues are there, ethical concerns are there, like algorithmic bias, algo bias against black people. If it is in India, it is against gender. Like there has been certain Amazon AI based recruitment system. Now this will make automated decision making. Now when this system was put in place, it was showing bias against women. Bias against women. Why this is happening? Because what AI has for reference? For reference, AI has the existing data. And if you look at the societal data, we as a society, whichever country, if it is in India, we have as a system bias against lower caste, bias against genders, third genders, bias against poor people, bias against tribals. These all are our social realities. Now, when we feed AI system the specific data, we are feeding a biased data to AI. Now, this AI is getting trained on a biased data, so its decision making capabilities are also becoming biased due to this. This is exactly what we have observed in this particular Amazon recruitment debate. So this kind of algo bias, that is quite a big ethical concern regarding artificial intelligence. Infrastructure gap, all of the other data, internet, social data, rural urban divide, all this you can bring into picture here. Now way forward, go through this. I'm not spending too much of this. Artificial neural network, this is the brain of AI. Why this is, we have put this because 2024 Nobel Peace Prize, Nobel has been awarded for the discovery of artificial neural network. So it becomes a little bit more relevant and high chance for being asked in mains 2025. So what exactly is artificial neural network? That is computational model mimicking human neurons. 3 layers: input layer, hidden layers, and output layer. That is how it functions. Artificial nodes will be there, connected and weighted edges will be there. It can autocorrect themselves. It can like make a circuit system which resembles the how the electric circuits are sent across through in our brains and neuro system. So that is what exactly is artificial neural network. Now applications, it is you can copy paste the applications of artificial intelligence. Other part of the answer, it's quite straightforward. DeepSeek, again, DeepSeek has sent shockwaves across the world, not just in US, throughout the countries. And this shows how powerful is the concept of reverse engineering. If you get a question from reverse engineering, never forget to write about DeepSeek. So what exactly is reverse engineering? That is taking something, taking what? Taking an already made product, dismantle it, looking what exactly is this, then learning the systems out of it and making your own product based on similar tech. So is this violation of IPR? To some extent, yes. US companies have been very critical of this DeepSeek, and Chinese companies stealing the ChatGPT and other intellectual systems. But from China, this is their way. Like either you can cry, US is so advanced in this. Like if you remember this, when Sam Altman visited India, he made a statement. Somebody asked him whether when Indians will be capable of producing something like generative AI, ChatGPT, something like this, then his comments were Indians are nowhere in scene. They're simply not good enough. It may sound insulting, but to some extent, this is the reality of India, not just in IT, in a lot of other sectors. We are good at backend, we are good at certain set of jobs, but doing cutting edge research, it's still like a monopoly of US and other Western countries. And here is where the Chinese is getting attacking, where you can see the data here. Yeah. How much is ChatGPT? It costs billions for developing even every single model, and whereas this DeepSeek has been developed for 5.6 million US dollars. That means a fraction, less than 1/1000 of what US companies are spending. Out of this narrow margin of funding, they have developed a product. Even though through reverse engineering, they have developed something that can shake the world, that can create a ripple in this AI ecosystem that is still evolving. So much data is there. Like there has been 600 billion or something fall in the market capitalization of Nvidia after this DeepSeek has launched. So some of the data is provided here. You can go through this. Technical innovations, you can see cost-effective model. Now here is, you can say, like sit back and say or say rubbish about Chinese, like what they're doing. Because they were producing cheap products, now they are making cheap replicas. But the reality is today the 12,000 per capita income, 1.4, similar to India's billion population with a per capita income 5 times that of India. Now, this is a really huge achievement, right? And how they have achieved? By doing this reverse engineering, by building cheap products and exporting throughout the world, by providing localized or say Chinese indigenous alternatives of what West is offering, whether it is Amazon, Facebook, Instagram, TikTok. TikTok is already having some Chinese connections. So whatever these Western companies are handing over, the alternative system China has developed for its own. So you can see either they have provided through reverse engineering, through cheap exports, through a lot of other XYZ happenings. They have mastered the art and they have provided value to their citizens. They have built a resilient economy. Today, look at the mobile companies. There is hardly any Indian company who is providing top tier tech. All the major companies are Chinese, right? Redmi, Realme, Xiaomi, OnePlus. All these have Chinese bases, right? So too much talks on China. So DeepSeek is showing Chinese strength in reverse engineering, and this is offering a lot of lessons for India, including strategic framework, cost-effective development, policy and infrastructure. And this has really accelerated India's AI mission. India AI mission is just DeepSeek. Ripple effect is India AI mission, and it's renewed interest in India AI mission. And what this mission, India AI mission, is trying to do, that is to develop its own sovereign foundational AI model. What is sovereign foundational AI model? A nation's capability to build, operate foundational AI models using its own infrastructure, data, business outflow, etc., business networks, etc. What are the key components? Foundational model, that is the crux. Then we have sovereign control, and self-sufficiency will be there. Arguments, again there is a debate. Should India invent the wheel? Or should India just adapt whatever is the developments that is happening in the West? Again, there is credible points on both sides, arguments in support. You can see the data framework, data sovereignty, autonomy, technology independence, and applications. Like we have our languages, 22 languages in the constitution, it's scheduled, and we have dialects, we have diversity of languages extending up to say 1600 or more than that languages. So for our applications, we need systems which reflects our demands, and this may not be so much feasible through if we completely depend for foundational models on this Western companies or Western models. So we need to invest on this. This is arguments in support. Again, arguments, constrained arguments or arguments against, which speaks about India's limitations. There is also a question of even if we want, can we? Can we? That is again, let's see where India AI mission will go into. Again, a question on India AI mission, you should have the hard facts. It was launched in 2024. MATE is the nodal agency. 10,000 crore, 10,372 specifically crore mission over a 5-year span. India under Digital India Corporation, 7 key pillars. This is target to have 34,333 CPUs, GPUs, 100 billion parameters, 7 pillars. What are they? Computer infrastructure, innovation centers, data set platform, application development, data safety institute, education and skills, startup financing, etc., etc. Significance, economic impact, the AI data points you can use here, strategic advantages, structural reforms, all these straightforward points. You can go through the material. I'm not fully spending the time on this. Let's go ahead. Again, one more US India's AI ranking before going into this. One more very important aspect. You need to recollect why arguments in support of like why we exactly need to like invest on building foundational AI models. In 2025, especially when Biden was still in power, US has put a AI diffusion rule 2025. 2025. What does US AI diffusion rule 2025 say is it kept, this was in response of DeepSeek, so it kept India's import of advanced AI chips to 50,000 per year. India was placed in second tier countries. Again, there were countries like China and some other countries were placed in more stringent provisions. India was not placed in the strongest stringent provisions, but India was placed in second tier countries where there is a cap on the how much AI chips or advanced chips you can export to these countries. Along with few countries along India were Israel, Singapore, etc. Now this is, you might not find it so much in, if you are referring raw materials like formulated current affairs capsules you are referring, you might not see this news. Why? Because in May 20, this happened in January, that was January 17 around, Biden goes and Trump came into power. So in May 2025, Trump, what he has done, he has removed the cap, removed the 50,000 cap, and he has started the renegotiations. So now we are on the negotiating table, and wow, as such there is no cap. Now what is the problem with all of this? The problem with all of this is we become dependent on foreign countries, like we are dependent on China for rare earths or critical minerals. We become dependent on this advanced technology of the future. That's why we need to invest our own foundational models. Now, we are going through a period where there is a rampant weaponization. Whatever is your strategic leverage, any countries, frankly speaking, shamelessly weaponizing it. China, they have trade advantage. They are shamelessly weaponizing their trade through limitations, through putting sanctions, putting these phytosanitary barriers, like we have seen during the COVID times. Like the Australia was in forefront of demanding like independent investigation into COVID, origin of COVID coronavirus and all of this. And how China has responded to this by putting phytosanitary barriers on dairy and beef exports from Australia. So whatever the country is leveraging, it is shamelessly, we are going through a phase where any country, even US, the Trump tariffs, what US has, they have the global system, they have the economic power. India is also, like US has been for last 4 years or so. US has been India's top tier export economy, export destination. So in this context, Trump tariffs is going to impact us. So what exactly Trump tariff is? Trump is also weaponizing the economic strength of USA. Sorry. Yeah. What exactly Trump is doing? Weaponizing the economic strong positioning of USA. So this is a time where each and every country is weaponizing whatever is its strength. In this context, and leaving open a evolving technology which practically is going to influence each and every walks of our life, that is very much stupid. So this world can add up to the answer. India AI investment ranking. India is currently ranked 10. There is some other ranking 12th. India is currently investing $1.5 billion. There are questions you cannot expect, but these numbers you can use in other arguments. Similarly, what Prime Minister Narendra Modi has spoken at this AI Action Summit in Paris in 2025, some of his quotes you can use in essay. is left hand, right hand bias. These also you can use in essay, ethics, and specifically if there is an algo bias or a bias, you can definitely use that in science and tech also. So you can go through this. I don't think too much of interventions are required. Small language models. This is very much important. Small language models. Again, what is difference between small language models and big language models? It is on how much data it is being programmed. Big language models like ChatGPT, 3.0 and all, this will be programmed in billions of data points. Now, this programming is a highly energy consuming AI. If we look at like environmental impacts of AI, environmental impacts of this is also again a very hot topic. Environmental impacts of AI. It is said that one ChatGPT search needs 2.9 watt hour electricity. This is 10 to 15 times that of the electricity required for a Google search. One query answering in ChatGPT releases 3 grams of CO2, or say 20 grams of, requires 20 grams of water. Again, AI data centers on a daily basis requires 3 million gallons of water. And this is the current rate, 2025 rate. And this is going to be, demand is going to be exponentially higher. And we always have the problem of how to manage electronic waste. Now, this is the context why small language models are important. Here, what we do is the skeleton, that is the processing capacity of a big model we take, but we train them not in general billions of parameters. We train them in a narrow set of parameters. If suppose a AI system has to be developed for students, which parameters are required for the student, which parameters are directly related to students, only on that parameters this AI will be trained. It is specific application based oriented like models. Rest you can read from here. Sorry, few millions to few billions parameters versus LLMs will be in hundreds of billions or trillions of parameters. Architecture, similar neural network will be used. Key characteristic, it will be compact, efficient, resource optimized versions of LLMs. Some examples, quotations are given here. Benefits, as I discussed above, the numbers you should give in your answers. Cost, efficiency, flexibility, business advantages. Challenges, performance limitations, quality issues. Again, larger, high, when you are training a AI model on lesser number of parameters, you are giving more scope for bias. Computational AI ecosystem, way forward and all, you can go through this. Next, again, blockchain technology. Again, what is easiest definition of blockchain technology? Not waste any second. Blockchain technology, easiest definition is it is decentralized distributed ledger. These 3 words are exact 3 words. If a question that is on blockchain technology, this has been on due for quite a long time. Like the technology is in use, you might be well aware, it is already in use in many government initiatives, especially in Telangana, land reforms and all. It's already being in use, but the UPSC has somehow not asked. So there is always a chance it is asked. A couple of years later also we have seen this in case of LEDs, the question on LEDs, which was asked not when it was given Nobel Prize, but a couple of years later. So you can expect blockchain technology, always it's a topic that is always in news, so you can expect question on this. What exactly is a blockchain? That is decentralized distributed ledger. That is, if this is the mechanism, a new data comes into picture, for the block representing this, the data is created. It will, like earlier kya tha, we have a new block coming, it will check the encryption key, then it will let and not let. This was the two options available. Now it is not having an encryption key, it is checking it with the whole distributed network in the ledger, not just one computer, the whole computer. And if it is matches with the whole computer, then this access is provided. If it doesn't matches, then access is cancelled. This is what exactly how this blockchain ledger is working. This is what exactly we call this a decentralized distributed ledger. Again, what are the how it is different? Decentralization, immutability. Like you cannot fake it. You cannot fake an entry in a ledger, because if you want to fake an entry, it has to be approved by the whole networks. Now there is no possibility somebody can manipulate the whole networks. Previously, if a cyber attacker want to attack the encryption point, these where the key is, he can attack that particular computer and make the changes, and he can steal the data or whatever. Now when in blockchain, the data is not stored in one computer, that is stored in say millions of computers. Now it is not feasible for this hacker or say unauthorized access to happen, or the manipulation to happen in all these computer networks. So this gives immutability, no intermediaries is required. Consensus mechanism, it works based on, like we had checked, it will go and check to each of the distributed networks. Round the clock operations, like especially in the financial sector, you don't need a third party intermediary to verify the transaction. So this can happen without say banking intermediary or other regulatory intermediary. Benefits of blockchain: security, transparency, efficiency, decentralization, additional cost, accuracy, global access. Applications: financial, IoT, smart contract, energy trading, all these, like wide range of from rural development to urban solutions, all these blockchain technologies is being used. Some of the government schemes like Odisha government's Shakti application, I think this Telangana government also has some land records program. Okay, trust you can go through this. Digital twins, let's discuss the next topic, that is digital twins. Again, what exactly is digital twins? It is digital replica of physical systems. Again, this is as a act as a digital model. Like whatever you have to check, whether building a road will be effective or not effective, whether doing something XYZ change will be effective or not effective, then this provides a digital model to check these thing. And in India specific, this has most applications in urban planning. Especially we have seen potential applications to all our urban solution, be it Delhi air pollution, be it what are our urban problems, tell me, Mumbai flash floods, Guwahati, or Chennai floods, or Yeah, Bangalore traffic, Bangalore traffic management. Fifth one, Ayodhya development. We are running little bit low on battery. Sixth one, Dharavi slum development, etc. So these all applications you can have applications for digital twins. Again, numbers, data, what are the key applications, other areas. You can go through the documents. Yeah, we will start with the metaverse. Before that, let me sort out this charge issue. So we will take another break. So let's continue our discussion. So metaverse, that is our next topic. What exactly is metaverse? Metaverse. This is nothing but a collective virtual space where there is a convergence of different virtual reality technologies. Like convergence of virtual reality, it can have augmented reality, it can have IoT, it can have other internet tools. The convergence of this into a collective virtual identity, and this is what is called as metaverse. Some examples you should learn about this, like games like Roblox, Fortnite, Minecraft. All these have gaming platforms which make use of the metaverse, opportunities of metaverse. Other options like MetaWorld, Decentraland, all these also uses similar alternatives. Now, Rust metaverse, what it is, what is its potential applications, virtual office, digital real estate, a lot of applications, NFT marketplaces. All these you can get info from the booklet. Challenges, concerns, virtual reality versus augmented reality. This is mostly a prelims topic. We already have a PYQ, but if a question comes, you should be having the premises of what exactly is this. Virtual reality, it creates a completely immersive digital environment that revolves like complete like this virtual reality glasses you might be aware about. While augmented reality, it is not completely isolating yourself from the normal world. What is it does is it overlays digital information and virtual elements into the real world. This is what augmented reality is. This is the major crux of difference, and due to this it will have its differences in its applications, in challenges, in level of integration, all these regulatory aspects, all these aspects. Cost, obvious, virtual reality is much higher cost, while augmented reality, like the Pikachu game, that is the one of the classic, I don't know the spelling, but the Pikachu game is one of the classic examples of augmented reality. 6G, what exactly is 6G? Again, I'm not too much, let's not go too much into what exactly is the aspects of 6G in the class, because it's a factual content topic. What is comparison with 6G, 4G, 5G, all this is given here. The numbers, at least the speed numbers you should learn. Rest of the numbers, if you're forgetting, it's okay. Latency aspect should also come into your answer writing. What is the potential Bharat 6G vision? At least what is the government schemes you should have a fair idea about. Economic potential, 1 trillion economic contribution by 2035. Way forward, all this turn into more connected devices. Like 6G form the basis of Internet of Things. This should be your like crux of your answer, or the context, broad context of this particular question. Internet of Things, what exactly is Internet of Things now? Internet of Things, it is a network of connected physical devices. That means now what we have, if we want to connect like smart homes, what is the technology right now? The technology right now connects all the devices. If a smart home light or the calling bell or the gate or the door, all this will be connected to a centralized system or the cloud-based system, and it will have a centralized control. Now, where IoT go one step ahead, it is a connected of physical devices. It is not just connected to a centralized system. Like everything, your speakers of your home will be connected to the, say, the curtains, speakers, and there is interconnection between this will be connected to door, and this will be connected to something else, and this whole will be connected as a network. So instead of connecting to a centralized system, there will be active interconnection between devices across the smart home in an IoT system. That is where IoT becomes slightly different from that of than other systems. Then the numbers, data, what is the potential applications in healthcare, in energy, in homes, all these are given here. You can go through this. Drone industry, again, very much important. Again, the context is the war that happened between India and Pakistan, and there has been active use of drone against India. So this has been in news. You should be aware of what are our legal options, legal aspects related to drone technology. Do learn how regulation is done in India. Do add, if it is not given here, do add these elements to the note. Let's not too much waste time here. Now some small news are there, like Kerala becomes the first state to mandate robotics education. Robotics is hardly a neglected topic. I don't find any specific UPSC PYQ in last 10 years from robotics, but if it is in the syllabus, it is there for a purpose, and you can get, of course, get a questions. And robotics education for class 10 student has been mandated by Kerala. So the details of the news you can read here. Robotics and sustainable labor. Robotics, better definition could have been versus labor. Robotics versus labor, what is the data, whether it is a threat or automation. It's also automation, whether automation and robotics is a threat to labor, or can labor work along with robots. So these kind of, on these kind of ideas you can have the question. Baki challenges, way forward, some mnemonics like chai model, all these government schemes with respect to India, all these are given here. You can go through the material. Now, very broad, very big, and a section from which there has been constantly questions being asked, that is space tech in news. And this is our next topic. So in space tech, what exactly is happening? Space and society, you can get a general question like how doing research or investing in India, always you will find question raised on whether should we invest the money on upliftment of poor people directly, or should we invest on fancy space programs. So these are, even though it looks pretty worthless question at this point of our lives, because all our lives are one way or other connected to different space tech, but still these questions and even editorials in newspapers comes across on these ideas. So again, you can expect a general question how space tech is helping society. In this question, only one thing, there is no dearth of points, there is no dearth of ideas in if a question direct general question came, how investment in space is helpful to XYZ society. So here you only need to take care of one thing, that your answer should not be narrow. It should be as diverse as possible. Like environmental aspects, disaster management aspect, these are directly which you can come to your mind. Agricultural aspects, education, water conservation, energy sustainability, economic impact, sustainability technologies, again expand it, governance, security, all other aspect, try to bring into your answer and you will get enough number of points. Global geospatial policy, again I'm not too much into explaining you the tech or something. No, something I need to focus on is from the next topic, that is from manned unmanned mission. Like some general facts on space you should be like the R&D fact of 0.65% of GDP. Like there are some fundamental aspects where you should not miss out the information. Let's discuss those things. India space economy. What is India's, even though we have huge euphoria around what's happening at the space sector, but still if you look at the hard numbers, what is India's space economy in 2025? It is just $8 billion, 8 billion US dollars, and this is just 2% of global space market. India is having only, despite ISRO, the success of ISRO, despite all the euphoria we are having around space, India is just having 2% of share of global space market. And what we expect is by 2033, we will be having 44, that is 5 into 5 times growth. 5 into 5 times growth by next 8 years. And this means we will be having 7 to 8% of global space market. And we are also targeting in 2033, 11 billion space exports. So these numbers, these are like hardcore numbers with respect to space. These you should be well aware of. Again, when you are writing any particular answer on space, you should cite the points like India space policy, 2023. What it most critical aspects of this particular policy was 100% FDI, and there is support for private sector in the name of in-space and other institutional supports. 1,000 crore venture capital fund for space startups. We already have a 300 plus space startups. At least you should be aware of some of the very famous space startups from India. For example, the Skyroot, which makes private rockets. For example, Agnikul, which focus on 3D printing of rockets. And why space is too much important is not just it does so much things, it will have a multiplier effect. Why we should increase our investment is space, because of the multiplier effect. That is, for $1 that is invested in space, it becomes economically becomes $2.5. So there is a 2.5 into multiplier effect in the space sector. Okay. Also, there is direct jobs, around 1 lakh direct jobs in India. So I think you get fair idea of what is the government policy. We'll see, discuss, we will do specific topics, we'll see. But this is the broad aspects of space sector that you should not miss out. Let's go ahead. Rest of the topics you can read, like Axiom 4 mission that is currently in news. The Indian Shubhanshu Shukla, the Indian group captain of Air Force, has been first Indian to go to International Space Station. So this has been in news. Why this is significance for India is in the context of Gaganyaan mission. Like Rakesh Sharma, when he went to space, in 1984 on Russian rocket, that was not having so much of a strategic or a continuity. Why? Because it was just a gesture type of going into space. Now in 2025, like 40 years down the line, things have changed. Now why Shubhanshu Shukla is going into space? Because as a preparatory phase for the upcoming India's global mission, that is the, sorry, one second. Yeah, preparatory phase for India's manned space mission, that is the Gaganyaan mission. So the context is the first Indian astronaut on ISS in 25 years of existence, second Indian in space after a gap of say 41 years. Shubhanshu, first Indian pilot to spacecraft to ISS. A lot of first you will get. ISRO invested 5 billion for mission participation. Sorry. Gaganyaan's preparation, that is the strategic importance for India for this mission. Scientific benefits, again microgravity, a very important topic from the context of this. Question can come from what are the microgravity, what exactly is this, and what are its applications. Now Gaganyaan program, again this is in news. In every month there you will get some editorials written, some experiments going on. So you should have a fair idea. This is India's first human spacecraft program, space flight program. 3 astronauts we are taking to low Earth orbit of 400 kilometers for 3 days. 3 missions to 8 missions we will be having. 2 will be crewed missions and 6 will be uncrewed missions. Total budget of 193 crores, and it is having a target date of December 2028. So India will become the 4th nation to have these capabilities, sending humans to space after US, Russia and China. Significance, you can go through this again. Microgravity is there. What exactly is microgravity? It is not absence of gravity, but a sensation of like no gravity. There in space, what you exactly see is not absence of gravity. Why astronauts feel weightlessness? This feeling of weightlessness is exactly called as this microgravity. And it is not just absence of weight or absence of gravity. It is because they are always in a state of free flow. Like in satellites, or whether it is moon or a man-made satellites, when it is placed at a certain orbits, it is kept at a velocity such that it will be sustainable in that orbit. And in that orbit, if it has to be sustainable, should be always in a state of free fall. And it is because they are always in a state of free fall, that is why the astronauts feel no gravity in space. It's not simply because of lack of gravitational force. There is obviously gravity is still strong at these ranges, low Earth orbits or 200 kilometers, all these ranges. But still we feel weightlessness because we are always, astronauts are always in a state of free fall, sorry. Now Gaganyaan mission, one thing we have here done a comparison, huge comparison on manned and unmanned missions. Now here I will just rub this. Few things you should be aware about. Basic facts of manned and unmanned mission you can read from here. But what you should be aware about is, like a manned mission requires human rating for the launch vehicle. And what does it mean by human rating? That is extremely highly safe system should be there. And how you quantify extremely high safe system? That is 98% reliability. And India has to develop new technologies, that is emergency exit system. And there is extensive astronaut training required. Astronaut training. That is exactly why Subhanshu Shukla has gone to space also. There is astronaut training, part of it is psychology training. Now, what is this training? Psychology training also required. Where the other areas India should be, like a human space mission should focus, is radiation management, another one is space debris problem management. These are all elements, new elements, which a manned space mission, especially the Gaganyaan mission, should be focusing. Like, these are, you can say, the challenges the new system India need to put in place. So this is why the even Gaganyaan mission, you can see a consistent delay that is happening. Again, one important interesting facts related to Gaganyaan mission is 60% of Gaganyaan mission components are contributed by private sector. This is again a step towards indigenization. Step towards indigenization. Rust space topics, or you can read it from the booklet, SpaceX mission, which is all details are provided here. January 2025, we have successfully completed the mission. Aditya L1, even though it is quite long, old, little bit old, but still there has been developments, recent developments. That's why we have put this. NISAR program, which is an Indo-US collaborative program. This you can use in other part of the IR and other sections also. Aperture radar joint mission, actually it is. And technical specification, significance, all these you can read from the material. We're not too much spending our time on this. Now we have few new missions coming up, including Venus orbiter mission. Basic details I'm not discussing too much. One few interesting things about Venus orbiter mission is why it is challenging. Extreme environmental conditions, like Venus mission compared to Mars mission, it's more challenging because of the extreme environmental condition. 460 degrees Celsius is the like surface temperature. Then we have a pressure of 90 times that of Earth. We have a corrosive sulfuric acid, highly concentrated sulfuric acid clouds that destroys the metals and components. And we have a so dense atmosphere that blocks 99% of the sunlight. This makes Venus mission, Shukrayaan, Venus mission much more challenging, much more difficult than, rather than the distance, it becomes the conditions in Venus adds to the difficulty of this particular mission. Other complexities are provided here. You can go through this. Similarly, Chandrayaan 4. Chandrayaan 4 is a sample return mission. That means we go there, we dig something, we take the material, especially from this Shiv Shakti point, which we have named in the southern pole of the moon. Then we take these materials and come back. This is what we are planning in Chandrayaan 4. Details, significance, all these elements you can go through. Mars lander mission, that is India's Mangalyaan 2. Second Mars mission, again Bharatiya Antariksha mission, that is India is having its own space station. And this basis for this is the SpaceX mission. because space station of ISS, what is the size of ISS? It is having a size similar to a football ground. Now, how you can actually make this? Do you really think that the football ground size launch vehicle has been launched into space as ISS? No, it was not built like this. How it is built? It was sent by parts and it was assembled in the space. So this is same which India can look for in its Bharatiya Antariksh mission. So for this, all basis is the SpaceX mission. That means you can send satellites and couple it with the whatever is the components that is having. We have a failure for PSLV. PSLV is India's safe bet. And this is the third failure in its history. And the reasons for failure, all these technical aspects are provided here. You can go through this. Reason behind ISRO's success. Again, ISRO, again, a lot of factors are given here. You can definitely go through this. Now, ISRO, why ISRO, where it functions? It functions under Department of Space, which is overseen directly under Prime Minister. This adds a lot of bureaucratic ease for ISRO. It doesn't have the ministry level setup. It is not functioning directly under any ministry. So fund allocation, whether it is bureaucracy, delays, all these things become like much more easily accessible for ISRO. At the same time, headquarters, which is also in Bangalore. Earlier time, this was like distant from political aspects, which is happening mostly in Delhi. These are other factors, it means non-technical factors. First, you have the other factors like cost. We already told that the small satellite launch vehicle, we are launching at say 4 million, 5 million, whereas the Falcon 9 of SpaceX is being launched at extremely high, 65 million. We have cost advantage, we have other factors, we have basic research, we have visionaries, which is a point not in your booklet. Visionaries like Satish Dhawan, which you have Vikram Sarabhai, like APJ Abdul Kalam, all these have contributed to the success of ISRO. But the other factors, like the political factors, like the administrative setup, all this also should be a part of your answer. NAVIC system, we have a brief discussion of what exactly is NAVIC system when we were discussing about the electronic toll collection. Now, there are a few aspects I need to point out. Why GPS is still much better or more in use compared to NAVIC? You have to answer. First point is coverage. GPS, it's a global positioning system. That means there are more satellites, around 30 something satellites are there, and these are providing services throughout the world. While NAVIC is an Indic system. That means it is specifically developed for the demands of India. And which cover area it is covering? India plus 1500 kilometers from the borders of India. So this is the coverage of NAVIC. Second is device ecosystem. Like basically the GPS technology, this has been in place from 1970s. So due to these, GPS is a highly mature technology. And due to this, we have a extensive device ecosystem that is available for GPS, which is not the case for NAVIC, which is a recent development. And we don't have much devices which are tuned to the bands of NAVIC. Then you can write our limitations. Our NAVIC 11 satellite system it is. Out of these, 6 out of 11 satellites are non-functional right now. So all this adds to the limitations of NAVIC. That's why even in your phone, you mostly depend on GPS, not NAVIC. Rest the technical aspects like range, like what is our future programs, all these are covered here. You can go through the booklet. NASA's Artemis program, this is a India joined, that's why it's significant for India also. India joined the mission. Though directly not India is not contributing, but India is also part of the broader framework, which include different stages like Artemis 1 to Artemis 6, which will make yearly. The whole objective of Artemis mission is using moon as a base for Mars and other interplanetary missions. So that's a very long-term goal, vision with a noble goal. So on these aspects, you can write answer, frame answers, India's role, India's position, all these aspects you can bring into picture. Applications, go learn some examples. This is Lockheed Martin. What is Lockheed Martin? This is the company which is building F-35s, F-16, F-22, Raptor, like THAAD. US defense systems basically as built by this particular company. It's a company name, Lockheed Martin. Now Jeff Bezos has sent an all-woman mission into space. You can go through the details here. And there has been a lot of criticism against this mission as a pseudo-feminism. This is not true empowerment. This is a few minutes of space experience by spending millions of dollars and no scientific aspects connected to the mission. All these are leading to the criticisms of this. Rest of the criticism keywords you can read from here. Space tourism, again, this brings our focus to space tourism. Numbers, 5 billion industry by 2035. What is India's share? All these aspects you can look here. We're not discussing again space constellations. Here, something has to be seen, right? Currently, space constellations, basic information you can read from here. What I want to focus on is the Starlink India issues. Why Starlink? India specific issues. Firstly, we don't have any mechanism how to actually be the regulator when Starlink is providing internet to India. So we have regulatory gap. Any new technology is coming, there will be regulatory gap. And due to this, it requires multiple clearances. And due to the regulatory gap, legal gap, these clearances were getting delayed. This was the first problem of faced by Starlink in providing its services in India. Then there was aspects of security because Starlink was not ready to share its data, reference data to Indian authorities. So we were in a fix whether to allow this or not. It was not on a level playing with the other internet providers in the space. So in the region. So security aspects becomes again important. Then this also lead to indecision. Then there were complications related to spectrum, local data centers, because Starlink doesn't want local data centers or data centers to be placed in India. Again, this is against Indian policy interests. Then cost, biggest problem, because India is already one of the countries where internet charges are extremely lower. The cost of Starlink is around 33,000 for installation and kit. Then it's cost somewhere around 4,000 per month. So this seemingly this is higher than the current available cost. So we need different models. So all these added problems, issues to Starlink implementation in India. Still, what is the current status? There has been a letter of interest that is being issued by NAVIC as well in space as well as the government of India bodies, and in future, like near future itself, we will see the Starlink and other systems in place. Space debris, you can go through the topic. We will speed up because it's already, we have crossed the allotted time span, so we'll just finalize these rest of the topics. Most you can go through this, any conceptual aspect is there, I will cover it up. Now space diplomacy, militarization of space, a very important aspects. Few things you need to keep in mind here, that is the treaty is in place. What is the most important treaty? That is Outer Space Treaty. Outer Space Treaty that was signed in 1967. Now, one thing you need to understand, Outer Space Treaty doesn't completely ban militarization of space. What it bans is, it completely prohibits nuclear weapons and other weapons of mass destruction in space. These two aspects it completely prohibits. It doesn't completely prohibits other aspects which may be connected to space militarization, like anti-satellite technology, like India's mission Shakti. All these aspects are not covered under the Outer Space Treaty, and due to this specific limitation, UN is negotiating the next treaty, that is PAROS. What is PAROS? Prevention of Arms Race in Outer Space Treaty. So this new treaty is under negotiation, but it's still not implemented. There is conflicts and all this going on. Rest militarization of space, what an interesting point is India's position. So India is developing its doctrine in space militarization. So you can ASAT capability we already achieved, that is anti-satellite capability through mission Shakti. Rest you can read from the material. Let's go ahead. Space diplomacy, very easy topic. Private sector in space, like a regular topic. Every year we put this news and UPSC never asks. So, but still, you should go through at least once some numbers. As I already discussed, Skyroot, Agnikul, these startups you should be well aware of. Numbers, potential, these all aspects you should keep in mind. Let's get ahead of space. Then now we have nanotechnology, quantum technology, biotechnology, and IPR. So we'll rush through the topics. We are not spending too much of time. What exactly is nanotechnology? When we are handling substances, or you can say of the size 10 raised to minus 1 billionth of a meter and 1/200 nanometers, when we are handling manipulating atoms or molecules at this scale, then this is called as nanotechnology. Now what happens at this stage? The surface area to volume ratio becomes extremely high. Due to this, the properties changes, and it's not like the properties of the original metal will be maintained, or original molecule will be maintained. It doesn't maintain, we get new properties. This is why nanotechnology becomes more and more significant or relevant. For example, gold. What color is gold? We all know it's a yellow color, yellow metal. But at nanoscale, we can have different colors, including red, including black, and some other colors also. So the properties you get out of nanotechnology can be completely diverse, different from that of other tech. So this is why nanotechnology is important. What exactly allows manipulation of atoms or molecules, or create or modify materials at nanoscale, and on scale mostly referred to 1/200 nanometer. Current state, market, all these you can read from here. Application framework, some mnemonics are given, go through this. Opportunities, market potential, targeted drug delivery, nanofertilizers. Before going into this, government schemes, all these, go through this. Not spending too much effort into it. Nanofertilizer, again a very specific news point. This cannot be asked as a question, but obviously you can use this in like agri-tech. You can use this in nanotechnology as example. As we had a question, if a question comes on nanotechnology, how it is helping farmers, you can use this particular example. Then how it is working, it is being sprayed, what is the efficiency, all these numbers, who is developing it, what is the potential, all this is given here. What are the challenges, all these aspects are covered here. Nanoplastic has been identified as the emerging agent in antibiotic resistance spread. You can go through this news, or typical editorial news, not editorial, typical news, explain news. Nanotechnology applications in health sector, this was a PYQ. Now, how to handle this kind of question? That is, you have to divide the health sector. If a question is asked, this technology in this sector, how you divide health sector, that much good your answer will be. Your answer should have some aspect on diagnostics, like PCR testing, all this, how nanotechnology helps. You can have new materials, you can have testing kit, you can have affordable testing kits, early detection, you can have a lot of other area aspects. Now, second, in medicine, you can have nanomaterial based medicines, you can have nano smart materials, a lot of aspects related to medicine. Other ways of treatment, like in surgery, nano robotics become surgical, nano smart materials, like in stent, smart stent, and nano implants. All these aspects nanotechnology has. Preventive healthcare, how nanotechnology plays a role. You can divide the sector like this, then your answer will be multidimensional. But if you think from nanotechnology perspective, then it becomes extremely difficult to generate points and your answer becomes narrow. And that is not what is expected in a UPSC answer, right? Quantum technology, nanotechnology, we are dealing with 10 raised to 1 to 100 nanometers. Here we are going a little bit more deeper, where quantum state become active, and some of the critical technologies superposition, where normally we have deals with bits 0 and 1, and quantum we deal with qubits, which can have infinite position between 0 and 1, and this property is called as superposition. Then we have entanglement, where any change in properties of one particular as fundamental material will result in consequent same time change in the other material. So this is what is entanglement. These are the two fundamental principles, or some fundamental working principles of quantum science and quantum technology. Now a lot of applications, all the other aspects, you can go through this. Rest I'm not spending. Indian quantum mission, national quantum mission, all these aspects has been covered in the material. You can go through this. Next we have biotechnology, quite easy, straightforward sector. Again, what exactly is biotechnology? We have life sciences, like animals, plants, molecules, cells, all these. Combine it with modern science, and what comes out is biotechnology. This is the definition you have to write. Okay. Applications, again, I'm not easy question, quite easy, but there has been a lot of pre-IQs. Role of how biotechnology can help farmers, how biotechnology can help society, all these questions has been continuously being asked. And recent government policies, bio E3 policy, E3 for economy, environment and employment. So this policy also we have covered in detail. Some data numbers, 16-fold rise we already seen from 2014 to 2025, and we are expecting much greater growth. So these numbers you can use in bioeconomy type questions. Again, government scheme Biosarthi, bio E3 policy, a detailed analysis is given here. Go through the policy. Not too much investing in these because of our time constraints. Again, the topics are not very quite difficult. These are like, you can read it from the material. Assam becomes the first state to adopt this bio E3 framework. India's bio startup ecosystem. India's bio startup, again, you need to know some numbers, you need to know some names. For example, C6 Energy, which is working on development seaweed utilization. Xcode Life, which is working on computational biotechnology. Similarly, the Ganga Gen Biotech. Some of the key examples from this particular sector. India's biotech ecosystem, the numbers again, by National Biopharma Mission. All the analysis you can go through Biotech Kisan Scientist Farmer Connect program. Again, this can be part of your agri-tech. Yeah, vaccines, mRNA vaccine. What is mRNA? All these are important because the recently in 2023 Nobel Prize has been awarded for this. So this is a hot topic, not just, and UPSC has continuously asked questions also from this COVID-19. This was too much in news. That much relevant is not there right now, but still it is a hot topic. Same goes with the DNA vaccine technology, how it is different from other types of vaccine, what are the benefits, what are the challenges, all these aspects. Antimicrobial resistance, a growing problem. What are the causes, consequences, all these special data is provided. You have to ratna chahiye, you have to memorize this data and go for the examination. There is no excuse for this, and revise this and memorize it. There is no excuse I want to hear. I cannot memorize, or I'm not good at memorizing. Doesn't matter what you're good at. What the exam demands is you need to write with these numbers and examples and data, facts and points. So you have to do this irrespective of whether you like it or not. Way forward, all these aspects are given here. You can go through this. Genome edited rice. Again, more importantly, Genome India project, which has been the first one, has been recently completed. So this is again in too much in news. So you should cover this in a broad manner. Again, the rest of the topics are stem cell technology. This is, you can see there has been a PYQ on this. This has been in news. There is huge potential for the technology. So go through this, what is exactly given in the material. I'm not spending too much time on this. Applied biotechnology research, like generic question. In generic question, the keyword, what should be the approach? That is how you divide the question. That is everything. In technical question, how much quality of points you generate. That is everything. So different question, you should have different content and different approaches. Again, some recent current developments are given. Last topic, that is IPR related issues. And in what is IPR, what is India's legal framework, what exactly are the current challenges. I'm not spending too much time because it's all basic factual information. Most of the content you already know. Our work has been to put it in one place, and we have done that. Now your work is to go through the material. Some traditional knowledge has been in news. Some why US is putting India in this priority watch list, all these aspects. What is the concerns, intellectual property rights concerns between India and US, all this is covered here. You can go through the material. So that's end of the material and end of the session. So on a parting note, what I want to say is this is a very comprehensive material. It has been developed with a lot of effort, and show respect to the material. You have to read it multiple times. It is not like one time you read it and you got all this. And many times it is all on the three subjects, IR, security and science tech. Most of the question you all know the peripheral knowledge. But this material will help you to go into the depths and answer with much more clarity, with much more qualitative points. So this is the expectation in making this material. Make the best use of it. Make the points directly from this particular material. That's the only way you can improve your marks beyond, say, 450, around 450 or somewhere in that ranges. So that's the end of science and tech session. Tomorrow we'll be having the international relations session, and after that the internal security session. On that note, I will wind up. All the best. Thank you so much.